we go. We are live. Try thinking.
Mobius Presents.
Yeah.
Yeah, you know what? This freaking blender screwed up. I had to start over on this stupid thing.
It's all right. I'll just keep Neil deGrasse Tyson saying Mobius.
Mobius.
Yeah, so I'm sitting here trying to redo all this stuff. Well, when you're doing things that are like this large in Blender, I'm not doing like actual size. I've scaled it down quite a bit, but in Blender, in order to show like close up of a surface of something that's as large as they say, quote unquote, something is.
Bad monkey.
Yeah, but I'm having trouble trying to work the controls. For one, Blender is not very Mac friendly. I don't know if anybody is aware of that, but it's a pain
Heavy
in the
Buster,
ass.
I think.
Yeah, so if you want to just give me a second, I don't know.
It's no rush,
Yeah,
man.
no
We're
rush.
just chilling.
Yeah, definitely not.
All right. Yeah, give me a minute to work this out because I had it all set up. I
Take a half
waited
hour.
on something. Yeah.
You're cool. Really? It doesn't matter. It's all good.
There you go. Right, sort this live chat out.
So used to being on the phone. It's so different on the computer. Discord is.
I'm just glad you don't have the garbly mic.
Oh yeah. I could go get it. I'm just gonna be bad monkey on this account. Could bring in the other account. Let me do that, see if it works.
Just trying to sort my chat out so I can see what we're doing. There you go. Oh, stop it. Wow, Bearded Devil is Flatsoid's not even here, is he? It's bad. Bearded Devil's got a thing for Flatsoid. Come and have a chat. I was wondering about Flatsoid with the... Because Tommy said he wanted to chat with Flatsoid, didn't he? A debate. You don't remember that? It'd be interesting to see what happened.
Yo. Oh,
So,
I made it back.
got 2 accounts.
Yep.
Gargly guy.
I'm not garbly. I don't think. I think I'll be bad monkey on my phone. That'll work. Oh, yeah, hang on. Yep, I knew as soon as we went live, I'd need to go eat.
Yeah, Flatsoid. Sorry, not Flatsoid. Mobius.
Mm-hmm.
It's not very loud though.
I think Matrix is coming over. He was just over at MEUK. He'll probably show up here. Get ready for a mic check. Mic check.
Yeah.
I wish Matrix was here.
Yeah. Somebody to do a mic check.
Get your wishes, my command. Mic check, what's going on, guys?
That's bad.
Yeah.
You allow Matrix here?
Yeah. You've got a little background noise. I'll be back in a little while, y'all.
Okay.
I'm just kidding. Matrix is the man.
So yeah, tonight we've got Mobius doing a presentation. Well, sort of a presentation. We're just going over some things we've found on Ligo. Again, seeing as that's the hot topic at the minute, especially over here. Actual geometry we can do with this rather than just pictures and we will.
I was driving before with one of my friends and we're listening to, I didn't want to go too hardcore with him, so we're listening to 24/7 and they were actually bringing up level, the earth is 3/4 water, you know, the earth is not completely flat. People are talking about it.
I'm not so sure about the 3/4 water thing. We don't know, do we?
Well, let me just say, according to their fantasy, right? We're battling their fantasy. So they're saying, they were asking, you think the earth is flat? So the guy responded, look, according to your fantasy model, we have to say that up front, right? You say it's 70% water, right? So the guy said, well, we know at least 70% is flat and level. Now we have land, right? We have mountains, valleys. People are starting to talk like that now.
The elevation of the land is measured from the mean sea level.
Yep.
So establishing what the water level is, seeing as every other level is horizontal, then it does make sense that the water level should be horizontal too.
Yep, it's starting to register. Yep.
It's quite a simple logical process that you have to deny basic logic and basic reasoning, basic deduction skills, bypass all of that.
Some brains are level, some are, some are curved. I guess some psychology people are straight, some aren't. I guess you can figure it out easily or not. I guess sometimes it takes a long time for some people.
Yes. Should we do an exclusive while we're waiting, Buster? Should we? Or
Hey, let it rip.
Yeah, a new song?
yeah.
New
Oh,
song,
cool.
brand new.
All right.
Oh, this is a good one.
Let me. What do we want? Should I put it in the? I'll put it in the. Straight in here for you guys. Then you can click on it at the same time as I do. Then you don't need to. We don't need to upload it to YouTube or watch it from YouTube. We can just watch it straight from the Discord once it's uploaded. I'll tell everybody in here when I'm pressing the button, and we'll put it on. This is a exclusive. We're just waiting to finish it off. It's going to be a dual sort of release when it goes out live on YouTube, but this is
Soft opening.
yeah, this is the teaser trailer. Here we go. Right, so I'm ready for everyone on YouTube. That should be easy. That's dead easy when you do it like this. Okay, here we go.
Come go with me.
Give us the countdown.
I'm playing it.
Open your mind.
Okay.
Skeptical mind was all I ever knew. Finding the knowledge of the real world starts with the point of which has no parts. These are the axioms of life.
It's on YouTube, so
chances with the old ways, finding the proofs in geometry. And I don't care what all the sophists say. I find the proofs in reality. 'Cause they were right. We know that they were right. Starting circles and lines alone, constructing the nature of what's known. Conclusions are clear and the evidence seen. This 3D space works perfectly, and I'll take my chances with the old ways, finding the proofs in geometry. And I don't care what all the sophists say. I'll find the proofs in reality. When all around you is sinking sand, you'll have a place on which to stand. Foundations were already built for you, so open your mind. And I'll take my chances with the older ways, hearing the words of what the ancients said. They say my words sound like sorcery, but there's wisdom in all honesty. Come go with me. Open your mind. Come go with me. We'll find the truth.
Beautiful. That is definitely the best one yet. Well, I don't know. I really struggle to find out which one's the best one. I love them all, Buster.
Wow, man.
Not just saying that.
Nice.
No. When he was dusting the mosaic with the brush there, I got chills, man. I got chills. Honestly.
When I was making that video, I had tears in my eyes. The missus came in. She went, "What are you doing?" I don't know, just making a song. I don't know what's going on.
Buster, the music, the thing, you guys killed it, man. I'm telling you, I got chills when I saw that dusting. Yeah, amazing.
Dude,
I was
in the Euphrates, what they were doing was they were damming the Euphrates up, and there was a town, 30,000 people, that was going to get flooded, and just as they were damming it up, they found a villa, and they uncovered all of that mosaic from an old Greek villa in that area, and it's flooded now.
Wow, when that face stares at you there, and you see, and you hear the song they knew all along, and it's a masterpiece, man. Congratulations, guys.
Yeah, John.
We just need your bit to make it even better.
Ooh.
Tomorrow you're gonna have the second part of it, the second part you requested.
All right.
Promise.
Booey boo bop.
I'll find some good stuff for that as well, and yeah, they'll be put out together as a pair. Oh, Nathan in the chat too.
I was trying to. I was trying to find some visuals the other day, like yesterday, to send to you, but man, you where did you find this stuff, bro?
I don't
Awesome.
know. It's the Logos just takes you, doesn't it? As with everything round here, you just flow. I woke up this morning thinking I'll just get that video sorted for Buster.
All right. I'm not sure if this will go over well, but
Are we going to try? Do you want to?
I
can
can
you go
try.
live, or do you want to do it by picture, bit by bit?
Yeah, I can do it. I can go live here. Let me see. What do I have to choose from here?
I'll try my best in control 3Space as well, but it'll be mainly on this channel. I'll be able to get you on here.
All right. Do you see there on the website there?
Yep.
Got the LIGO laboratory as-built drawings. Got architectural, civil at the Livingston Observatory there. Click on the architectural.
Yeah, just a minute. Let's see
And-
if I can get 3Space up and running
Here.
as well on the presentation. Oh, that's good.
Oh, okay. You doing all right?
Yeah, I think 3Space is good. Have we got the audio working on 3Space? I think so.
This is just I was just going to go over the architectural and civil drawings for the levels and all that stuff, the elevation levels for the different structures, and go over some different things on there. And then on Blender, well, I don't know what happened to Blender. It seems like that program's kind of weird, but I did do a screen recording earlier of what I did in Blender, which was basically create a structure. It's scaled down, but a structure similar to LIGO, at least it's straight, which LIGO is supposed to be straight, on a sphere, on the surface of a sphere. And it shows, where if you have a point of tangent, either at the apex or whatever, it shows what would happen, in regards to where the distance would change, obviously, right? Because
Yeah.
a tangent doesn't curve.
There can only be one tangent with a point of it.
Right.
LIGO being orthogonal, there can only be one tangential point if you're taking the geometry of the globe geometry anyway.
Right. It's a right angle, right? It would be two straight arms linked together on the same horizontal plane, going in two different axes, right? The y-axis and the x-axis.
Yeah.
So it would only have one point of tangency. It wouldn't have 2 points. Anyways, so let's see, on that LIGO, on that architectural drawings, I don't know if you can see my cursor at all, can you?
Yeah.
Oh, okay, cool. So over here, legends, symbols, and abbreviations. I'll just go over this real quick just because it's here. These are all just like take a screenshot of all these or whatever. Then down here, floor plans and all that. I didn't really get into a whole lot of that because that's just kind of like an overhead view. What I wanted to do is get into the elevations, the whatever. So up here it says horizontal joint gives a, this is the, real quick, let me show you what this is. This is the corner station. So like would be the apex where the two arms meet.
Yep.
Up here it says a horizontal joint, 24 feet above elevation. And that line extends the entire length of that structure. Same thing with down here. There's a horizontal joint, 24 feet on this part of the structure. And down here it says the datum point elevation at 100 feet 0 inches. Over here, that's basically like their baseline.
Yeah.
And then that elevation equals 61.44. So everywhere where it says on this particular thing, 100 feet 0 inches, it means 61.44, 61 feet, 61.44 feet. Sorry.
Yeah.
On that portion of that structure and on this portion of that structure. And these are the two different areas of that building where the long tubes enter into this structure. All right, so there's that.
Yeah, got that. So basically what they've done is they've set a datum at 100, but they do know the actual elevation of that one that they've set at 100, but that becomes the new datum. They just set it at what they call it 100, but that's just
it's 61.44 inches, but they call it 100 because that's like their baseline.
Yeah.
They just basically set the zero, I guess.
Well, set the 100.
Right.
Yeah.
Set the zero at 100, whatever. So then we go to the mid station, plans, sections, elevations. And this, again, gives you the elevation, the datum point elevation, 61 elevation for station B, mid station B. So these are the different arms, and these are the mid stations of those arms. These are the overhead drawings here, and then here's the vertical. So that's where the tube sits, right? Elevation at 100, elevation at 100, which equals, like we said earlier, down here, depending on where you're at, mid station B is 61, mid station A is 63. So that's what that 100.
Right, so their elevation datum at what they've zeroed at 0, they're calling it 100. But they then say that 100 changes to different ones because you had a 64, a 61, and a 63.
Yeah.
In the different, right? So their basic straight line is staying the same, but they're saying that the actual elevation of underneath is changing. 61. They've got an arbitrary numbers that change underneath their standard elevation. Yeah.
Right. Yeah, because they've got grade, and then they've got their where the buildings are. Here's the end station building elevation. And again, this will tell you the different stations. Here's 57.46 feet and 61.49 feet for station A. It just gives you like the drop down, like what they're built different ways, right? They've got different.
Yeah.
Right. So, and what I found really interesting was on the civil. And this, let's see if that one, what was the one that I had? Might have been general notes, legends and no, it wasn't that one. here. I think it was this one. Yeah. So this one gives you all the like the location, like where it is, how big it is, right, in relation to like the area.
Yeah.
Right. These coordinate tables and elevations. And then this tells you like over here, let's go down here. Down here is LIGO 1 is the southeast arm. LIGO 2, LIGO 3, LIGO 4, and LIGO 5. Where's it? Over here. Right, for the different arms and whatnot. So over here it says LIGO 1, 50.1859 elevation, LIGO 2, LIGO 3. So LIGO 3 and LIGO 5 are nearly identical elevations, which means this arm, the end of this arm, the southwest arm, and the corner station are nearly identical baseline elevations. I thought that was kind of interesting. And then this has some notes. GPS coordinate points are high accuracy. LIGO 1 and 3 shall be reestablished by contractor in a new location to be determined. So this is just a drawing before they start actual breaking ground and all this stuff. This is their plans, right? Drawings are plans, not, real life. So just to keep that in the back of your head. And then the vertical control elevations shown are mean sea level, datum NAVD 88, which if you look into that, that's a whole other, can of worms. Elevations are a least squares adjustment holding to NAVD 88 values of NGS adjusted. Elevation of benchmark A290, Y21, and S294 vertical order first class. These are these guys over here, the 42.1193. It doesn't show that on here, but that's anyway.
Yeah.
That's their benchmarks, which might have been like, I don't know. I don't want to say something I'm not totally.
Well, I will say that the first order, I looked into that, is set with a coincidence bubble level, which is an optical device. It's one of the highest orders. It's a fantastic piece of kit, but that is optical. It's not GPS. They set the antennas or whatever for GPS for alignment purposes, but then the actual first order measurements would be taken with this optical sight for a line of sight coincidence bubble level. That's not GPS assisted, but that would assist the GPS, if you know what I mean, to make it first order at least.
Right, yeah, I get you. And here too, it gives the apex. So we know where the actual, like, where they started, right? The very corner of this development. It gives the coordinates here, which if you look at LIGO 3, which is the corner building, right, where the two arms meet, it's very close in proximity. Right, so it's the apex is like right around here somewhere, where LIGO 3 is.
Yeah, in the center of LIGO 3, that would be, wouldn't it? That would be the apex, because that's the arms that they're after, isn't it? And the buildings are built around it.
Right.
Yeah.
And then also on the civil, this is where it gets really kind of weird. So this right here is the Southwest arm plan and profile from station 0+00 to station 14+00. And I have yet to find out exactly how those numbers are being used, but it seems to be in relation to the scale down here where is it? You can see down here, this is the corner station. This is the first leg out of all of these sections. And here's the horizontal scale. 1 inch equals 50 feet. So if we go up here, I think this is 50 feet. This is another 50 feet. So each one of these 12 to 13 is 100 feet.
Yeah.
And this will show the beginning over here on the left at 0 plus 0, 0, and then 100 feet, 200 feet, 300 feet, and so on. And it starts off at this line here, I would say, where it starts at the most, like, closest to level, 64.05 feet. That's elevation. This is the top of the concrete slab beam tube enclosure. And it has an arrow pointing there. And then it's got rough grade there. And then it continues down. So from this first leg right here, it goes to 63.12.
Yeah, I was just looking at those. In the step down, it seems very linear, doesn't it? It's like 2 or 3. It goes down 2 or 3 or point.
Well, yeah, and then there's some very interesting stuff later on. Because yeah, it's stepping down. But if you go like midway, so this is a southwest from 0 to 1,400 feet, then from 70 to, or I'm sorry, 56 to 70, I think it was. So this is, you can see in the corner down here, it's like midway. And then, oops. 6303, 6302, 6302, 6301, and so on.
0101 00000.
And then this is 6300, 6300. Like, there's no change in elevation throughout this whole section. So from 62 feet, or 6,200 feet to 6,900 feet, at least on this. And I think it goes on to like 70 or 7,100 feet.
No, that can't be right. 7,100 feet. It's overall along the length of the arm is 4,000 meters, isn't it?
Yeah, it's like 2,000. What is it? 2,150 some odd feet or something like that. Well, this is halfway.
Yeah.
This is, like I said, this is like midway of this arm.
Taking that geometrically, if you were to look at that and give them their due, that they're adjusting it to the ellipsoidal model, just looking at that having the 0, 0, 0s, you would say that would be the tangency point, right? Midway along one of the arms.
Yeah, I mean, that's, you would think.
Yeah.
Because, you know, that's going off of mean sea level, right?
So, well, yeah, I think, didn't he say that that's the least squares adjusted? So they are taking they're adjusting actual measurements to fit the ellipsoidal model. Because they have two different models, don't they? The NAV whatever and the WGS 80. And then the ellipsoidal model rather than the geoid. Gets really confusing once you start with the globe geometry.
Yeah, because then you got 3 different things to choose from, whichever fits, right?
Yeah.
All right, so then going down to the end of that structure, the southwest arm.
Nathan's saying in the chat as well, no canal on the map. Have you actually seen the canal marked on the map or not?
No, but I did want to, in a little bit, I was going to go over,
touch on
I found some stuff in the plumbing drawings and the concrete drawings. It's got everything in here. Everything that's gone into building this structure is within those drawings. All the plans, anyway.
Yeah.
Which I want to remind everybody that the plans are just a precursor to the actual build. It's not necessarily the build, right?
Yeah.
To be determined by the contractor at the time of the build. Right. So here's the end station. And then, so from here to here, the very end is 64.09. So we've got 64.06, 64.09, whatever.
Yeah, you're getting
so that one
0.04 of an adjustment there as you get into that end.
Right. So the corner station, if we go back to the corner station, so we've got 64.09, right, for the end station.
Yeah.
Right. Go back to the corner station, which is where it all started. It's 64.05. So it's the same elevation.
64.09 you've got on the left-hand side of that, haven't you? You do.
Well, that 64.09 right there, and then it was 64.09 at the very end also.
Yeah.
So it's the corner station. Well, I have written down 64.05, and then the end station 64.09. So they're about the same. Anyway, the middle is what drops down to 63. Or 62, I'm sorry. No, I'm sorry. It is 63. That's right. There was that long stretch where it's all at 63 feet.
Yeah.
0.00. So that's kind of a weird, it's from mean sea level, 64.05 to 64.09 over 4,000 meters.
So it drops down and then goes back up again to.
That's what it says in the profile drawing here. Yeah.
Wow.
And that's on the southwest arm, and then on the southeast arm, you get other stuff totally different. So we scroll down here to the southeast arm from 0 to 14 here. It goes to the start. Zoom in. Starts out at 64.05. So it's this section right here at this, 64.12 over here, but this section was 64.09 in the other drawing, and 64.05 at this section where it says 63.99. So I don't know what that's all about, but the beginning, I call 63.99 because that's where it starts to be the same.
Well, that drops down 0.06 right from the off, whereas the other one was dropping down 0.03 per drop. Wow. Well,
this is at the same corner station. It's just the other
the other side, yeah.
Yeah. So that's a difference right there in elevation, just from at the apex. Really?
Yeah.
Right? So it's kind of weird.
Yeah, very.
Now, I don't know if I want to go through the whole, like in the middle and all that. I can go straight to the end just to show the profile on the very end here. Just so that we can see. This is 60.03. And this continues, what did I write down? From 124 to 130. Down here on these, I went through the other page earlier. It stays at 60.03 for whatever that distance is, right?
You say that's an end point?
That's the end point here. Yeah, this is the end point at this side.
Wow, well, that geometrically, that would be another tangency point, wouldn't it? Where there is very, like, is that patch where the other one was stayed the same? Is that patch about the same length?
No. Well, no, it's well, if I'm doing it right, I don't know if I'm doing it right, but I gathered that each one of these sections was 100 feet. So if that is correct, then one of them was 600 feet long and the other one was 800 feet long. The even elevation stretches, according to the drawings. And this one was towards the end of this arm, and the other one was in the middle of the other arm.
Yeah,
which is where it dropped down and it went back up.
Yeah.
So it drops down and goes back up here on the southwest arm, and then it just gradually goes down in elevation on the southeast arm.
According to the numbers, right?
According to these numbers,
just the numbers go down. We're not saying that the arm goes up and down. It's just the numbers on the plans.
It
Right.
cannot go up or down. Not even a fraction of a millimeter of a whisker of a rat's hair.
Well, they can build it however they want, but obviously it's not straight if it bends.
Yeah. Or it's just the numbers on the model that they've adjusted, and the numbers are giving them these problems, let's say. I mean, I wouldn't say the problem. They're not problems for us, because like SE says, this thing's meant to be as straight, right? It's the straightest thing. So claimed.
Well, then I'll go over that video I made earlier with the Blender program. But real quick, I wanted to show, let's see, what did I look at before? These don't highlight when you've gone over them like the drawings do, but I think there was, is it the floor plan? I'm not sure. This isn't really that, no, it wasn't that one. If it's highlighted, then it'll maybe flow diagram. Maybe that's what I look. No, let me look at that anyway. I don't know. Oh, these are overhead. Sorry.
Have you looked in the interior where the laser is and stuff like that? Or you're just looking at the foundation and stuff?
Yeah, earlier it did show like the what was it? Where the beam tube is located.
Yeah, that's where the gravy is.
I just wanted to show real quick. I can't remember what it was on the plumbing, but that wasn't really that big of a deal. What I thought was interesting is on structural, which is like the concrete stuff. Where does it say the concrete? Is it steel? Let me see. Foundation. Framing elevations. Was it that? I don't know. Something that I saw. Yeah, maybe it was. Something that I saw here that I thought was kind of neat. Was it on this one? Sorry, guys, bear with me. Actually, I don't think that it was on this one. Yeah, it's kind of hard to read anyway. Got some smudges.
I have a question for you, Mobius, after.
Yeah.
Or I can ask you now while you're doing this. It's up to you.
Yeah, go ahead.
Did you get a chance to check the elevation between the ends of the arms? You know, the square at either end? Because there's mirrors there. Was there any discrepancy at all? Let's say between the 3 points.
Yeah, according to those numbers, yes.
Well, that's game over then.
Yeah, so on the corner station, I've got like 64.05. Of course, it varies from which arm, right? The southwest arm, I've got 64.05. The southeast arm, I've got 63.99. So there's a discrepancy there, 0.06 feet. And then the southwest arm in the middle goes down to 63 feet and then goes back up at the end to 64.09 feet. Whereas the southeast arm starts at 63.99 and then gradually goes down to 60.04 feet. But there's a long stretch of about, I don't know, 600 or 800 feet from, what I gather that the distances on the drawing indicate to be the same elevation for 600 or 800 feet.
Yeah, so
That's a problem.
one end drops down near 4 feet, and the other one drops down a foot and then rises back again.
What?
Yeah.
Oh, okay. I'm gonna let you finish. I got some information. I'm biting my tongue. Sorry. Go ahead.
I'm just trying to look on here what I looked at earlier. I wish these drawing numbers on the left, I wish that they would highlight what you've looked at, because
yeah, but now they'd all be purple because you'd been looking at them, wouldn't you?
Yeah.
If you had a strong enough computer, you could keep opening windows. You could keep opening windows for each one and put it in your OBS.
Oh, yeah.
And then save each window for each OBS.
Here,
window.
this is what it was.
Nice.
So these
I'm
are
back. If it makes you feel any better, I'm back.
I feel safe, like a warm blanket.
I figured.
So these are slabs on the grade, right? Let's see down here. It's got the where's the detail? This one. I think the other sheet's got the detail, like where these things are located on the development. But does it say it on this one or the other one? Maybe they say it. Oh, dowels to match vertical reinforcings. Vertical. Well, if they're all vertical throughout the entire thing,
they'd be parallel.
Yeah.
They'd be parallel, right?
They had to be.
If it's straight, yeah.
So how can they have a
universe?
How can they have something vertical at the end of the thing and something vertical at the other end of the thing when they're both parallel or they're both perpendicular to the thing? You know what I mean? It's kind of weird. Anyways, yeah, let me.
You're saying you think maybe they should have had to adjust one of them a different orientation
to not be vertical.
Well, yeah, I mean they're either vertical or they're not vertical.
I was just poking the bear.
Here, this was just a screen recording that I did of the Blender thing, just because I figured I'd record it instead of. Oops, what happened?
Ooh.
Let me get that back up. Hold on. Let me go back to this for a second. I don't know what I did.
There you go.
What? I'm not having any luck with this stupid Blender program.
Do you have a separate screen in your OBS for Blender?
No, this is on Discord. You're not doing this through.
Oh, you're not using OBS. Sorry.
No, yeah.
You just need
to try it again.
Yeah.
Here we go. Now I gotta find
you're
that
good.
stupid window. All right. So I tried to kind of keep all the detail over here on the sides. Can you see my cursor on this one too?
Yeah. Yep.
Oh, cool. Awesome. So this sphere, it's an isosphere. Gonna zoom out here a little bit. Can you see Louisiana?
No.
No.
We can imagine it though, if that's what you want us to do.
Okay, yeah, there you go. So let's see, I'm trying to. Here we go. Where I come and zoom in. Need some music while this is going, I guess. Buster. That's as far as I could zoom in before it started clipping. And then I hit this little thing up here where it gives you like, it snaps to orthogonal. So this is zooming in. Now I put the apex as a tangential point on this particular structure. This is scaled down, obviously, because otherwise it'd burn up my computer.
Yeah.
But that's the elevation difference at the end of, what arm did I call that? The southeast arm. Right, that's the elevation difference. It would be higher, not lower.
Yeah.
Then I just kind of scrolled over to the end.
That's sweet.
So that
keep
that's
scrolling.
Drop at the other end as well. That's where your tangent point is, yeah?
Yeah.
Yeah.
What I did is I just basically put two blocks together, two cubes. Then here's the other. Do I go to the other one?
Oh, you've
Yeah, this is the southwest arm. You can see over here on the right.
Yeah.
So both arms are the same elevation. You know, it's obviously it's not an ellipsoid, but if water is even over this surface, then that mean sea level that they gauge it from would have it lift over. It would rise in elevation at either ends of these arms.
Yeah, the arms would rise due to the water would be the sphere, right?
Right.
Yeah. But that's not what those numbers were saying, is it?
No.
Yeah. That's
Man,
weird.
I don't know if I had anything else. Did I have anything else?
I wonder if we.
No, I think that was it.
That would be Jesse Kozlowski. Who else is a surveyor? I don't want to put Larry Scott on the spot because we know that Larry doesn't really know much about it.
He's just an actor.
Yeah.
Here's what I have too. I did. Sorry. I wanted to show you guys this too because this was Google Earth. I'm sure you guys have all gone over Google Earth and all that before, but
what's Google Earth?
Yeah.
No, I'm just kidding.
Oh, we're still on your. Oh, here we go. Yeah. We're with you.
Yeah. So let's see. Like a kind of a side-by-side comparison of that OBS, right? I just kind of like. Now this is the Google Earth flattened, right? They take an overhead shot and they just kind of distort it to make it look like you're, it's 3D, but it's not actually 3D.
Yeah.
But there's the Ligo Livingston, right? There's the right angle of the two arms.
I reckon they just did 3, 4, 5 to build that.
Yeah.
Probably, right? I mean, that's a feat in itself, right? So there's that canal, right? And then there's some, let me pause that real quick. You see how Let me go back. You see right here where it's like dirt in the canal?
Yeah, it's been overgrown. Or, I mean, that could be a moss or, you know, something like a floating plant or whatever.
Right. Well, it does interrupt the elevation of the water.
Oh, right.
Right, because if you
So
have
it is
like...
a block then.
Yeah. So I just wanted to show that real quick too, because it does get like solid in between there, and then it picks back up again. It's basically where water's
Is this
just
a more
settled.
modern one though, right? These shots here are the when are they?
This is just
taken?
from Google Earth today. I don't know when it was
You
taken,
don't know
but
when the Google Earth was updated with the pictures
No.
because that looked like a lot cleaner canal originally.
that's a southeast arm, I believe, and then I also do the same thing with the southwest arm here in a second, I think. I don't know. I was kind of dicking around with the whole thing, but trying to navigate with the mouse. You got to hit
It's cool
certain...
the way you're doing that, so people could see like how long this thing is. Like it's 4 kilometers.
Yeah, it's long.
Yeah.
Look at that.
With a canal right next to it. It's kind of weird.
Yeah. Look, it extends almost to the horizon there. Like this ain't no joke.
Would that
And
be
here's-
three? Would that be 3 coplanar points on each end and in the
Yep.
at the apex?
Well, you'd hope so, wouldn't you? But not according to those numbers he's just been through.
See,
Their
3
machine
points.
cannot work.
Yeah.
There's blocks in the water here too, up ahead, like where the midpoints and stuff up here. There's some blocks, but either
Any
way,
3 points can establish a plane.
you know, when you're up in an airplane, this is what you see too. It's kind of weird.
I think that one going across the middle of them is a transcontinental pipeline, isn't it?
What, this one right here?
Yeah, that one there.
Going across?
Yeah.
That's power lines. I think that's a right of way for transmission power lines.
Yeah, I think I read in the plans that's transcontinental or whatever.
This one might right here might be, but
Oh,
I think
yeah,
the one
yeah,
that goes
sorry,
across them is the power
They
lines.
shouldn't really have power lines running through there if they're shooting those lasers. That's kind of weird.
You know, it's weird because high voltage creates a hell of a lot of like static charge in the air. It ionizes the air, and you can hear it if you've ever passed by power lines. You can hear it crackling. I wonder what kind of noise that does on that laser on the mirrors.
That is
Well, I
weird.
can tell you all about that.
Oh yeah, you're chopping at the bit, aren't you? Here, I'll
You can
stop.
say that.
I'll stop the streaming. That's all I got.
LIGO
Nice.
looks like a right triangle to me. 180 degrees.
Yeah.
Threw an extra line on it.
I think it is, isn't it?
Yeah. A right
Yeah.
angle, perfect. Or yeah.
Right, have you
Yeah,
got,
Rocky, I
you've
thought
got
you'd
something
get a kick
for
out of
us,
that.
Essie? Have you got a presentation or just got some stuff in the chat?
No, I was just I was dying to say some info about the accuracy of the beam and stuff like that.
Are you gonna they say us or naysay us right now?
No.
Naysay.
I was doing research on this. So, according to the specifications of this LIGO, it's 4 clicks, either arm. On either end, there's a mirror. It's 40 kilograms, about 80, 90 pounds. It's suspended by
Glass.
glass
Glass
threads. They're like I don't know how many times less thinner than a human hair.
Half the thickness.
And it's like
I think I heard half the thickness of a human hair.
way less than half. Way
That's
less than half.
That's what they're suspended on?
Yeah.
Yeah, they tried the wire before, but they found that it was too noisy.
It probably picks up the induction from those power lines.
Oh, more than that, all kinds. First of all, the whole mechanism is suspended in springs, sideways motion. It has multiple vibration dampeners.
Well, real quick before I don't mean to interrupt you too much. I don't want to get side railed, but as far as like
please, are you kidding? I love this.
Like anything floating, I don't know like how familiar you guys are with, electrical stuff, but anything floating will it's subject to induction. Right? So it'll build up a capacitive charge if it's not grounded. So if they use wire and it's totally isolated, especially with those high voltage power lines, it'll build up a charge, an electrical charge, and anybody that touches it'll get shocked, like walking your feet across the carpet and touching your cat's nose, kind of like that.
Oh, that's mean.
Oh yeah. yeah.
That might be why for 8 years they didn't find anything, right? I see.
Yeah. 8 years. The first one, that was the first LIGO. 8 years, they found absolutely nothing. Cost them like $500 million. Then they gutted the whole system and they put this new system that we're talking about now. And what he said is very important about the wires. That's one of the reasons why they changed them, because they made noise. So what they decided to go with the glass fiber, which a special company, I believe in Glasgow, made it. Anyways, whatever. So now it's quadruple pendulum. It's not one, not two, but four. It's an apparatus. And it's suspended by these fibers, and it has to stand completely still, because get this, it has to detect a motion less than a proton. I think 1,000 times less the diameter than a proton.
Yeah.
So they're saying.
Oh, go ahead.
Oh, go ahead, bro. Go ahead.
I was thinking about it yesterday. I was thinking about what they say about it, and then what they do. What they do is they shoot a horizontal laser beam 4 kilometers down. It bounces off a perpendicular, a pendulum that's vertical. So, and then the light bounces back 280 times. What they demonstrate is that horizontal that's 4 kilometers long is perpendicular to those vertical mirror ends right there.
Yeah,
that's amazing what they're demonstrating. Yeah.
Yeah. Now check this out. It gets worse. It gets much, much worse. Now, exactly what you said, bro. These things hanging have to be, they're 4 kilix apart, right? Now they have to be balanced so precisely that I believe the term is a nanoradiant. So now I checked that out.
That sounds like radio.
Yeah, it's incredible. Put it this way, not to go too much into detail. It has to be a line less than the wavelength of light.
Wow.
Which light?
Light, what we call light. The wavelength of light. I forget. They measure it to a ridiculous, crazy. Just research nanoradiant, I believe that's what they call it. And this is like 20 times that. Oh, another thing. The tube that this laser, which is invisible to the naked eye, by the way, they have to give you special glasses when you enter the facility. Anyway, what was I saying? Oh yeah, the vacuum tube, get this, is evacuated to 1/1000th of the air that we breathe. That's what they claim. Like a bunch of nonsense.
Holy shit.
And it's
on a vacuum for something that big.
It's on a motor system as well, that they like a seismology thing that senses what happens to the land and adjusts the whole system to make sure that the whole arms and everything don't move if there's any movement of the land underneath. It's fantastic when you hear it.
Amazing. Check this out now. One more geek thing. Listen to how powerful this thing they claim is. They claim that at the other end of the state, they can pick up the lapping motion of the waves, and they can tell you if there's a storm approaching.
Oh my God, that's so cool. It's like science fiction. Man.
Yeah.
It's La La Land. But yet, check. They were able to pick up something, 2 black holes colliding, 1.3 billion.
No, they weren't.
I'm saying now, keep in mind, we're in fantasy La La Land now. They're claiming this. They claim that they can pick up 2 black holes colliding, 1.3 billion light years away. They were able to filter out all the noise between us and that happening. It's delusion. Okay, I said my piece.
Almost unbelievable.
Yeah. This one here, this one, I think this is the Indian one that they're planning on doing. But the vacuum says there of a nanotor, 10 to the minus 9, which is fantastic.
Amazing, that is. Oh, incredible. One final thing. I gotta say this. This is only phase 2, right? Phase 3, this has to be said, and LIGO is going to be in space. They want to do this in space. Shoot out laser beams and make arms and, imagine how much believe it or not,
It'd be a nice ride. LIGO in space.
Can I just point out the fact that these are pendulum or pendula, and they sort of hanging by things. There's no adjustment to the hanging mechanism of the quadruple pendulum.
Quadruple, yes, sir.
Then that would necessitate them being in the plumb position. They would be perpendicals, wouldn't they? Hanging down. They wouldn't be vertical. And in order for all of them to be having the light pass through them, you would... I
like how Birdie Charlie was talking about that a minute ago, about how... Yeah. He was saying that vertical in those construction drawings doesn't necessarily mean vertical. It just...
Really?
Yeah, in general. He said
to
in
go
general.
4 kilometers and bounce backwards and forwards 280 times claimed before reconverging all the light to then measure a particle's movement of a wavelength or whatever. Then, you'd hope that they would all be in line, really.
Yeah.
Vertical, like parallel, hopefully.
Not only vertical, but the most vertical thing you've ever seen in your life, like ever designed by human.
I mean, it would have to be, right?
Yeah.
The most vertical thing in the universe.
Yeah.
We're talking 4 clicks here.
And
the straightest thing in the universe.
All of those being at right angles, perpendicular to the laser beam travelling through them. And bouncing it back. I can't see any other way, really, to have parallel verticals.
Well, as a matter of fact, that's how they aligned the mirrors, funny enough, with the laser itself.
Yeah.
That was the only way they can do it. Yeah, there was this woman that figured out how to do it.
I guess
you can YouTube all this stuff, everything that we said. We're not making this stuff up.
Yeah, Bilu could have been a consultant on the first phase or whatever, and they were like, "Damn, this shit up. These are tilting away. This alien's an idiot." So they fired his ass, and they came back out and had to redo everything the right way.
Yeah.
But
Ooh.
8 years, they thought it was the way to go, though. For 8 years.
That was the first one. Was that the first take they did in Washington? I think Lego one, and they
Yeah,
figured it
Funny
out.
enough. Oh yeah. This should be mentioned.
Helu,
After they degutted it and they fired up the new one, it detected the waves in 1 day. That should be mentioned.
That's right.
yeah.
I wonder if
Helu
they're
had to wait
funding.
for the Helu had to wait for the next transfer ship. They only come once every 8 years, so.
I'm not making any claims, but I would be curious what their funding situation was after close up to that point.
I can tell you, close to zero.
No,
Then
but
they
I
got
mean,
miraculously another, I think, $300 million boost to
right.
degut them.
That's what I mean. Like, oh, you guys are gonna get decommissioned. We're gonna wreck this place out. It hasn't produced anything for 8 years.
Oh,
We're gonna move
It's
on.
a whole story.
That's when you say, do over. Let's do over. We fucked up. Come
I need
on,
a
let's try
mulligan.
again.
Then surprise, surprise. Oh, hey, we found something.
Oh, good job, guys.
Yeah, it was well worth
Right.
that money, the extra money that we spent on it.
Let's give them a raise. Put
Oh,
some more
by the
money
way,
into it.
another thing that just came to my mind. They built in a false detection system to keep the scientists on their feet. So in other words, and this is important. How did I forget this? In other words, only 4 people out of the 5,000 or so scientists involved knew when this false event would take place. In other words, they were able to make it look like an event happened.
So they lied to them all.
Yeah, did they test it like a day after they refixed it?
Yeah.
Was that a real one or a fake one?
Yeah.
Yeah, that was real.
There's
Yeah,
only
thanks for
4
the
of them
funding.
that knew. It's like, yeah, it was
Wait.
real. It was unreal.
Why do they have why do they have safety things like that in place? So that people won't lie?
So there only a
No,
few
they
people
say
know.
their own words is to keep the scientists on their toes.
You
Yeah,
mean
right?
They would have
They-
to.
to keep the
In other
scientists from lying?
No. Well, yeah, we know that. I mean, it's all bull. But the way they say it is, when they detect an event, right? Only 4 people know if it's real or not. But the scientists have to go through the motions, get the mathematics, call the media, and then at the last minute they'll tell them, okay, it was bull. Don't worry, we don't have to do this.
How could you
So-
keep a
so
secret for thousands?
So there's a built. So
mean,
there's
how
a
could you-
built-in polygraph.
Yeah.
Yeah. I guess.
How could you
yeah.
keep a secret like that when you have thousands of scientists involved? Oh wait, only 4 of them know the truth. Okay, yeah, that's possible.
So that's what I'm trying to get at. Like, there's a fail safe for in case a scientist is going to lie about something, right?
No, I don't think it's for that. I think it's just
Yeah.
meant for. They got to take everything serious, like a fire station, right? No matter what alarm comes in, they got to suit up, right, and go to the. You know what I'm saying?
Oh, I thought you were saying that there was fail safes in place to prevent like scientists from fudging the numbers to make it look like something
Well,
that happened.
Their story is that they only have 4 people in the know, and they have false readings sometimes. So the scientists just detect what they see, but those 4 people know whether it was fake or it was real. They could
Exactly.
have all been fake.
It was a false positive, right?
Exactly. Yeah.
I wonder why they. I wonder why they would go through the trouble. I mean, scientists don't lie. Nobody's ever, they've never deceived anybody ever for money. That's never
Yeah.
happened.
You're tripping.
Yeah,
That kind of blew my mind when I heard that. I go, what? Why would they do that? Well, I mean, really? You have like a fake detection thing, like a fake gravitational wave detection causing thing? That's weird.
Yeah. When I heard it, I kept saying the same thing over and over again. Why would they lie? Why would they lie? Why would they lie?
I think Kimo made a song with that.
It's a
Shout
good thing
out
we know.
Kimo.
It's a good thing we know how water flows.
Yep.
Show enough.
Yeah.
Yeah, look into this, and I'm telling you, there's so much more. You're gonna laugh. Just YouTube it. There's like 5, 6, 7 videos of themselves. All this that I'm telling you now is from the scientists themselves that were responsible for this.
Yeah, the science doesn't even work out either. It's all based on faulty science, gravitational waves, time, space, dependent variables that don't even match.
Well, I think there is real science that, it's practical and usable, but when it gets into the imagination, then it's,
Well, because they go off Einsteinian gravitational science, I think, but they don't use that, and it gets all the real hard science doesn't even work out when it comes down to the physics.
Look at the vacuum enclosure. Nice find, Bev. Look at that. We're supposed to believe that that thing is a billionth time less than the air we breathe, and it's been there for years, and it's sealed perfectly. Come on.
Now, is this like the same thing as the first one, the LIGO one?
They only kept the outside, I believe, the shell, but they degutted everything inside. The vacuum, the mirrors, everything. That whole system got degutted.
what I want to know is how the hell something that like expensive and, delicate, how the hell would they let someone like Zanuck roll a bowling ball down the tube? You know what I mean?
Well, there's only one arm that it would roll down, wouldn't it? I mean, like one of them, it should roll all the way to the other end, and the other one would actually roll to the middle, wouldn't it? Because
it's bent.
Yeah, it's bent down in the middle on one arm.
Well, Zanuck, Kosho, George, Nunchuck, they all said that the arms lift at either end. They're higher up.
Yeah.
That's what they all said. Yeah, I don't know. Maybe they haven't seen
I'll
the plans for it.
show you the it's that gravitational thing, isn't it? They've obviously looked at that.
Gravitational potential or something like that. Something ridiculous like that, right?
Well, wasn't it in the Ordnance Survey? I'll go get it here. It's made a fair bit back. I've made a few since that one. Oh, put it in the wrong bloody chat, did I? Yeah.
Oh, yeah, you put it in the wrong.
Yeah. Here we go. I'll get it. This one. I'll find it again. There you go. And that is from I know I put arrows on it because it was a bit hard to see what the blindfolded guy, where his blindfold was and where he was looking. But yeah, I think that's why they are saying that their model dictates the uphill arm.
So there's a special gravity field there. Wait,
I don't know. You've got to put your brain in a special place to be able to.
so they figured out where the gravity was at before they built the thing that detects gravity waves?
Well, Rakio
gravity
was
field.
there the other day, and he said he felt his truck kind of lighter when he passed by there. So, I don't know. Maybe, yeah.
Careful, don't pinrose yourself.
It's an anomaly.
Yeah. He was going downhill, but he had to accelerate. Otherwise, he wouldn't go all the way down the hill.
Yeah.
I can't find the full one. But yeah, that's what their model says has to happen, obviously, because it's got a guy looking down and it says up. So that's the backwards world that we have to live in nowadays. If you believe you live on a model, then that's the sort of ridiculous thing that you have to believe in, isn't it? That up is down and down is up. Open is closed and closed is open.
Now, you think it'll be easy to keep that kind of 10 to the minus 9 torr for all those years? Think it'll be easy to do that?
As far as I heard, that 10 to the minus was the strongest vacuum that they've ever had here where we live. And that's a small chamber. I don't know how they've managed to do it on 2 4-kilometer arms. Reach a 10 to the minus 9. That's
amazing,
massive. That's some pump, that, isn't it?
Wow.
Technology must have advanced.
Apparently, Bev, I heard that they got to bake it, to get all the stuff out of there, as much as they can. They got to heat it up. And now if it leaks, they got to do it all over again, I heard.
Dry air. I could
must be
understand
some
the dry
kind of,
air thing.
Yeah. I saw the one they did in Germany, and they said, well, that's been there for like a few years. She said, I would have to do that all over again. The rebaking process, the vacuum. Yeah, it's a lot more than people think it is. It's not just turning on a pump and, boom. Then you have the seals. Now imagine 4 kilometers of seals have to be perfectly vacuumed.
They can't keep that vacuum running constantly. They've only run, as far as I know, they've only run 2 runs of whatever they do, whenever they do to test it. Because it's shut down at the minute for COVID. So they can't be still keeping the vacuum and all of that running when they're not doing a run of the...
I would imagine not, but I can't really speak to that. I haven't researched that part.
Yeah.
But it's quite an undertaking, eh? 10 to the minus 9 torr there for 4 kilometers on either side. Wow.
Well, not being a vacuum expert, but yeah, I think that is the largest vacuum I think I've ever heard of. I don't know if we've got any
Same
vacuum
here. I've
experts.
heard that CERN may be even bigger, but don't quote me on that. I think this is the second one. This is a while ago I read that. Now, I could be wrong on that. Please don't quote me. But I think CERN is larger than this one.
My only experience with the vacuum was in a little small lab setup, and it was about a $10,000 pump to get down to 0.1 torr in just a few glass tubes. And you had to change the oil in it every time you used it. So I can only imagine a 4 kilometer and getting, how many times would that be? 0.1 torr to point.
Is that exponential?
0. Yeah. I can't fathom that.
You see that? The little bit of writing that came with that is... it says why the gravity field is important in height measurement. On the left is a hill in a uniform gravity field. On the right is a flat surface in a non-uniform gravity field. The white dotted lines are level surfaces. So obviously in the one on the left, that level surface is it's flat, straight. And the guy that's walking up the hill is walking up the hill, and it says level at the top, but it just means he's not going up nor down because he's level. And the guy that's walking down is walking down. Like the gravity field looks like perpendicular verticals, that as you would expect. Now the one on the right is obviously different, but it says here the experience of the blindfolded stickmen is the same in both cases. Like the experience of both of those guys is the same in both cases. From this, it is clear that the gravity field must be considered in our definition of height. And I don't know who the our is, because it's definitely not in my definition of height. I've never queried anybody on the gravity field when talking about the height of anything, ever.
This is delusion,
Yeah.
sheer delusion.
It says this is
One
why
of
the
those guys-
geoid is a fundamental reference surface for vertical measurements, not an ellipsoid. So for vertical measurements, which is the datum, vertical datums, we don't use the ellipsoid. We use a geoid. And as we all know, that's why he's called flatsoid, because the geoid is a flat model.
One guy looks.
Go on.
That one guy looks drunk in that gravity field, falling forward and falling backward. I can't imagine that would be normal.
He's falling. The
Sorry,
one that's
Phil.
falling down's falling up. The one that's falling over backwards is actually looking down, falling up, or looking up, falling
Oh.
down.
I see. It makes absolutely no sense.
Yeah. Yeah, I think that's what it's meant to be. You're meant to go, oh, really? Yeah, I'm not going to talk to you. So yeah, the one on the right is what the globers obviously imagine, with the ends of the arms going upwards, because their models dictated it to them. Those of us that just live in reality will always experience the model on the left of the two, the number one. Those of us that get blindfolded and who want to imagine you live on a ball, well, you can imagine that one on the right. Your choice. I mean, I'm not going to I'm not going to tell anybody that they're wrong or anything. If they want to imagine that, they can. I'd prefer if they didn't say that we were stupid, or I was stupid, or anybody else is stupid because of my understanding of reality only ever being able to experience that one on the left. But no doubt there'll be some globe geometers / surveyors that should be able to explain all of these problems that they seem to have within the varying heights of things. Bertie, there's no curve in a horizontal. There's no curve in a straight, which these arms are meant to be claimed as. And the mirrors are pendular, so they are vertical. So if the light's bouncing through them, it has to be horizontal, and the verticals have to be parallel. Canals
I
at the
think this
side.
is the.
Go on. Sorry.
Oh, no, I'm sorry. I think this is the second biggest sham sold to the American public after the moon landing.
Yeah, I'd have to go along with that. The lengths and the costs that they go to fool people of something that I don't know. I don't believe it. The measurements
they
don't
just
seem
wanted
to
to-
count.
Yeah, I just think they wanted to see if they could shoot horizontal straight lines out that far and bounce it back on that vertical mirror. They just wanted to test and make sure that there was no curvature. But they had to do it under the guise of gravity waves so that taxpayers could pay for it.
Got an interesting development in the chat. Troll problems. Obviously, Cog Dis is kicking in. Bertie Charlie
Obviously.
says water levels can't determine the shape of the Earth.
What?
Yeah, well,
What?
I'll say that again. We know how water flows, Bertie.
Woohoo.
We do that. And for you to say that you can't determine, so you can't determine whether it is curved. Because we say it's horizontal. The water levels are a tool for establishing a horizontal plane of reference. If you say you can't determine a curve with them, then wow, that leaves you at a bit of a problem, not us.
Cheers.
Yeah.
Hey, Bev, I was looking at this book earlier, right there.
Oh, yeah. I'll get that up on chat. Yeah, to determine the surface of a liquid between two parallel vertical plates, let DAP be a section of the surface of the fluid and of the parallel plates made by a plane perpendicular to their surfaces.
Mm-hmm.
Wow. Is that the one, the book that said that the surface is horizontal?
Oh, this right here? Sorry.
Bam.
There you go. The surface of a fluid at rest is a horizontal plane. Oh, well, that'll be why all of the verticals are always perpendicular to the surface, wouldn't it?
Yeah. Funny how that works.
Hmm.
No 2D planes on a 3D object.
Wow. Well, that would be like fluid mechanics. Would that be a scientific sort of thing? Hydrostatic equilibrium.
Oh, yeah, that's from the premier source right there for hydrostatics.
The elements of hydrostatics.
Yep, that's kind of like Euclid's book, basically, right? The elements.
Yeah, break it. Once you break stuff down to the fundamental first principles, then you end up with the elements of different things, and this is the elements of hydrostatics.
Ligo.
Shut up.
Wow.
Shout out to Gambino.
Linear interferometer gravity wave observatory.
And notice who made it, Parsons. Jack Parsons. If you saw one of those files that he was showing, it had Parsons at the bottom.
Of course, he's been dead for
Really?
a long time.
Yeah.
Yeah.
Oh yeah, he was that's where they made JPL in Pasadena. That's
Yeah.
But they have Parsons there at the bottom.
Oh, way up. B-Ball's coming.
We got the tool abuser.
Yeah, here we go. Look, he's done a thing there. Look, you can phone that number up, like Rakia might do, and they might be able to tell you about boats going over, disappearing over the horizon if you ask them anything about. That LIGO arms are long enough that the curvature of the Earth was a factor. Really, people, come in and explain to us how you've got it one arm dropping down and then going back up again, and the other one just going down, according to the numbers anyway.
Those lasers don't shoot straight. What's going on here, man? It's horizontal, right? Say it with us, horizontal.
Oh, look at that as well. I mean, you've got right angles. You've got he's drawn a square. I mean, that shouldn't be possible, should it?
Bertie Charlie can't get off of playing My Model Dictates.
Yeah.
But you want to be perpendicular to a gravitational wave? Wouldn't you want to
Look
be...
at the next scam that they want to put on the American public. I just posted it.
Gigantic. Does it say how big that is?
Gigantic.
Gigantic. No, it's a satellite or a series of satellites. It's two. I didn't even.
Is that the
Looking
one
at
that's
it,
going to
it's
be
a
in space?
Yeah. That's LIGO in space.
There's already a bunch of them in space, 3D space. They're already here.
You know what? I have a globe Earth prediction that they'll never show you the construction of that device.
I wouldn't take that bet.
Yeah, it might be a nice little project for them to, get some actors out there and
Siphon some money.
Yeah. Yeah, 20 meter sections. Wow, that's quite a lot of stuff to get up there, isn't it?
Yeah, it's in the works. Look at the other one. They've been showing you the two black holes. Yeah.
Yeah, well, we'll be able to see it, as it's passing through the sun or the moon.
I wish we had DP to make a Pac-Man of LIGO.
Whack, 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 whack.
Whack, 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 whack.
Hey, look at how happy those two black holes look.
Instead of the ghosts, it'll
happy as hell, bro.
Instead of the ghosts, it'll be little globes.
We got noticed. All these billions of years here swirling around.
It does look like it does look like the blue ghost upside down in a Pac-Man.
Finally, we've been noticed. Smile.
Got some googly eyes.
It's freaking comical, man. People believe this shit.
That taxpayer money made those black holes happen. Thanks, Michael.
Just the timing of that announcement too, kind of strange.
Like nobody sees it funny. 8 years, nothing, and then the day after the new system comes in, they detect waves.
Yeah. Is it just me, or all these announcements just like getting more and more just insane, and like people just go with it?
Mobius, can you do that in your blender and put the Pac-Man as the LIGO arms, please?
That'd be funny.
I'll put it through me.
Oh my God,
me PNG
that's the same
maker.
thing.
It's
That's what I was saying. I just pointed that out.
That is crazy.
LIGO in space. Space.
Yeah, do a gift of that.
Where are all the stars in that picture?
LIGO in space.
Yeah, that was cool.
That was better. Nice.
Do a space ghost.
Space ghost. It's the straightest thing in the universe.
Dude, that's bitchin'. That's cool.
Busters on the move. It helps if you have a sound mixer next to you.
Oh yeah.
Trying to find that robot from earlier. Oh well. Danger, Will Robbins.
Oh, Blue Marbles. Obligatory comment in the chat. Talking to Bertie, of course.
Oh yeah.
Come on in, Blue. You can explain to us about these elevations, how it's all done.
He was struggling with the tangent point the other day, though, so I don't think he would.
Yeah. Well, he might have been looked into it and found out where the tangent point was on his model.
Is that Blue Marble silence?
Yeah.
Maybe Blue can explain to us what a nano radiant is. If I got that right.
I think he means radian.
I'll be right back.
Yeah.
No, Blue can't do that.
Oh, Blue is good in math, so maybe he's heard of this. He's an engineer. From what I know, they measure the wavelength, the length of light and frequency, and it gets very complicated. This nano radiant stuff. I barely scratched the surface, but it's very, very, very small. Like that stuff.
The thing that gets me is it can detect the ground shaking or anything, and it just makes itself impervious to any sort of earthquake or anything. That's the funny part about that.
Yeah,
I'm glad
it
you
can
mentioned
sense
that.
it beforehand and then make sure everything moves accordingly to make sure the system doesn't move. Even though they've got things on Pendula anyway.
Yeah, that's
Chat
the ground
sense.
aspect part. But they also have an algorithm. Get this, La La Land stuff. They also have an algorithm to separate all the other noise, they call it, from the electrical towers that you were saying, bro, and from a car passing by, from a truck, from... It's ridiculous, bro. It's ridiculous.
Well, they
And then
have
at
to
the
say that stuff,
Wait,
right?
wait. Blue Marble said he didn't struggle explaining it. Everybody else had struggled understanding it. His explanation.
What, where he said he didn't know where the tangent was?
I don't know. In the chat, he says
Yeah.
he didn't struggle. You don't.
Yeah, he did.
Oh,
He said he couldn't give us any numbers because he didn't know where the tangent was. I mean, seems like that's a Blue struggling to understand where any of the numbers would be.
Yeah, one's like going down, the other's going up and down, and going sideways, probably.
Would that be like the old science fiction, the wind from the sun? Is that what they're calling a gravitational wave?
Ooh,
Arthur
yeah,
C.
could
Clarke?
be. Yeah.
They had parachutes out there. Or something. I don't know.
There's your solar winds.
Mm-hmm.
Did hear about that, but wasn't that the so-called, I don't know. I've seen like models of things and like computer generated things about how like mylar unfolding arms and big umbrella type things.
Unbelievable.
These are the Sataloons. Come on, guys.
Level World says he's asked Jesse Kozlowski when water flows and about his measured drop. He's convinced that he's right. No, he's not convinced that he's right. He's got a model that dictates that is what has to happen. That's why Jesse Kozlowski says that. The water level drops from the horizontal plane at a rate of 8 inches times the distance in miles squared. No, I didn't say that. They're Jesse Kozlowski's words. When asked how to measure it, he comes struggling. Like Blue. Struggle because a drop from horizontal, a measured drop from horizontal, is what we term an elevation change. And as we know, the water doesn't change in elevation. It stays level. It's a tool for establishing a level.
Oh, Blue Marble's back in.
If LIGO was in space, wouldn't it be spinning around, generating its own gravitational field, like they talk about in science?
Update from Blue
fiction?
About the tangent. Do you know where the tangent is? Question mark. Please tell me. He's not done any studying, so this is Blue. This is how Blue does his researches. He comes to us to ask us where the tangent is. There is no tangent, Blue. In order for you to have a tangent, you need a circle or a curve. There isn't one. It's horizontal, Blue.
Ouch.
He says the literature says, my model dictates, somewhere within the triangle formed by the legs, depending on site conditions.
It's somewhere out there. You just gotta find it.
Can I ask a question real quick?
Yeah.
Was Freedom Frank in VC over here, or at Emmons?
No, he was over here. I think he came over here a couple of days ago.
Yeah,
He
he's
was in
gone
DC
now.
though, right? In voice.
Yeah.
hmm
Yeah, he's saying he's never been in voice before over there.
Yeah.
No, he
He
definitely
lies.
was. He came in and had a chat. We might have even been live, were we? I think we were, weren't we?
Oh yeah,
Yeah, we definitely
absolutely.
live. That'll be on record. That.
The whole thing.
So, and you'll have to go and find out for yourself, Blue, wherever you think the tangent point is, because we know there isn't a tangent point because you can't have a tangent to a horizontal.
The point is that which has no parts, Blue. Good luck. Good luck
Mhm.
finding that tangent point.
Blue, if I may ask you a question, can we have a hump or a drop without elevation change? If you were to be so kind.
Oh, that's a good one. I like that. Is it possible for us to have a hump or a drop without a change in elevation?
I know the answer.
Yeah,
Blue, what's the answer?
without swearing.
I'm curious. Blue is an engineer, right? Everybody knows Blue is an engineer. So
Is he? I don't know if he's an engineer. He makes got some nice finish on his woodworking.
Yeah, he's a good
look,
wood
I can't
finisher.
match his woodworking. I'll tell you that. So I'll give him kudos for that.
All he says is bottom of page 8 and what is that, Blue?
Is that where he thinks his tangent is? Which
Blue,
book?
do you,
which book
have
are
an
you
answer?
reading from, Blue? My model dictates book 8.
The Book of Lies and Deceit.
Ranty's Book of Optics.
Kind of blurry print on there. It's hard to read.
Also, I pride myself for having a clean garage, but it's not as clean as Blue's.
Bev keeps saying we're not an entertainment channel, but I swear we
well,
do have a lot of fun.
Yeah. We try and make it as entertaining as possible, this education that we're giving Blue. You feel educated, Blue?
Well, it's entertaining in itself, talking about this stuff. It has to be.
It has to be.
Yeah.
It has to.
Yeah.
All right, Blue, did you hear SE's question there? You have an answer? He'll never answer.
Yeah, personally, I feel hurt because I like Blue. We go a long way back, and I thought he would answer that question.
No, Blue, I think... yeah, no, I think YouTube are taking links out. I don't think you're allowed to post links, not even if you're a mod. So if you want to come over to 3Space, I'll get you a link. You can pop us it in on 3Space. I don't know. Did Blue join the other day, Cleary?
Yeah, he's in.
He's in here.
Mm-hmm.
I'll drop the link anyway in case anybody else wants to.
Yeah, I don't want to put you on the spot, Bev, but I didn't know if you had a clip from the last time you talked to Blue and he was talking about elevation.
I'll get that. I think I called it Elevation Blues.
That's pretty good.
What's his donkey's name? Phyllis or something? It's like, hey, Phyllis. Gladys, yeah, okay.
Blue, you do know you will be respected, right? Ain't nobody gonna yell at you or call you names here. You know that, right?
Yeah, I'll mute myself. Don't worry.
Me too. I won't ask any taxing questions or anything. I'm sure the boys can deal with that on their own.
We didn't say anything about taxing questions. We said respect. We sure as hell are going to ask taxing questions.
We still got DM here, so, come on in.
We'll talk about woodworking.
Throw some softball questions.
I don't think anybody here can compete against Blue in woodworking.
You guys hear that Blue Marble clip?
Yeah. I'm gonna play it now, guys. So I'm pressing play on the clip here. So Don't jump in for a bit.
All right.
Like I said, if you wanted to, like maybe somebody might have already done this, right? But it in between the 100-meter lengths of water level, you could put an auto level, right? And if you can establish that the auto level checks the water level, I don't know why you'd be doing that, but I mean you could use it as a calibration tool. You could calibrate your auto level with a water level, because you'd know that the water level establishes a horizontal. So you could put an auto level in the middle and check that one level is the same as the other level of the water level. Of course you could do that. Somebody's probably done that before to make sure that a level is level. But which one of these tools do you guys reckon is the level? The auto level or the water level? Which one is most level to you guys?
Can I ask a new question, please?
Can I ask? Can I get somebody to answer a question? Which level?
The water level.
Go on.
Water level, Bill.
The water level is the most level.
The water level will show you level.
Okay.
If you'll take your auto level then to the center of this array of level points that you've established, set it at the center, and then shoot both ends.
Yep.
You'll find out that they're dropping.
What? Both ends of the water level lower than the middle.
We got a hump.
You've got a hump.
Absolutely.
It's a hump.
We got a humpus.
Yeah.
You got a home face.
Nice. What about if you stood at one end? What happens then?
You'll shoot above the far. You'll shoot above the far one every time.
So that's a drop.
Yep.
Would you not get stuck at the middle bit that was higher?
It's a drop any. It would be a drop any direction you go. The Earth is always dropping away from you.
So the water. You think the water level drops away from you?
Yeah, I know it does.
Like a measurable from the horizontal, like you say, right?
If you'll do what you said, set your auto level up at the center, and shoot both ends, or set it up at either end, and shoot to the far end.
Yeah,
you're going to find out that it won't match the water level.
Right, so it's a drop. Now, can I ask you, because you sound like you're a bit knowledgeable, what do you call a change in vertical in surveying? Like if there's a vertical distance change, what's that called?
It's elevation, and it's measured from sea level.
You've just said that the water level changes in elevation from the point you're at.
The water level does. Yes, the water level will. Absolutely.
It's not establishing a level. Wait a minute. I think you might have got. Whoa, yeah.
Hold on.
Go on.
Hold on.
Take a mulligan on that one. Let's try again.
Don't overtalk.
Yeah.
Don't overtalk me.
Don't Penrose yourself.
The water level is going to establish the same elevation at every point.
Okay, so it's not a measurable drop from the horizontal then.
And to get voice meter working, it certainly will be. It certainly will be. The water level is not measured horizontal.
A measurable change from the horizontal is. Go. I'll pause that.
Good.
We were just going over
your Blue live.
Yeah.
Blue live.
Yeah. We're playing your clip there, Blue.
Welcome, Blue. Welcome.
So how you doing, Bill?
Fine, thank you. We're having some fun with this elevation and drop of the water level from the horizontal, perpendicular verticals. It's a bit of a geometrical quandary you've got. Your models put you in, isn't it? I think.
Yeah, I don't think so, but you got a place I can post this link? I'll show you what I'm talking about.
In the live chat if you can.
I know you were looking hard the other day for that tangent point. Yeah, live chat. It's got a green balloon next to it, right above the voice, right there.
Oh, wait a minute.
You put it in the chat thread there. No, scroll down a little.
I'll stick it in the live chat. Got it.
There you go.
There.
You got like a screenshot of that?
Yeah, I'm not.
That PDF?
No, I think we've got this already. 43 page.
That's the only documentation I've got on it.
Oh. Can you post a screenshot of what you have, or is that?
I'll get it. Is it just that first bit that you're after? You know, where it says.
Oh, you're asking about the tangent point, and page 8 and page 9 tell you about it.
Page 8, page 9. Okay.
So
Bottom of page 8 and top little bit of page 9, I think.
So the tangent point is somewhere in between the ends of the arm, somewhere in there in that triangle. That's what I heard earlier. So it could be anywhere. It's everywhere, right? The horizontal is tangent.
It can't be everywhere. It can only be at one point. That's the problem.
Yeah, but at some point,
you can only have it
very
at
specific,
one
is it?
point. And it was laid out, dictated by the site conditions. So where exactly they picked to establish the tangent plane, I don't know. I have no idea what they picked.
Do you think you should be able to tell with the water, though? Do you think you should be able to tell with the water or with the surveying that they've done?
Oh, I think you very well could tell, or at least get a general idea with the water level. What you want to get is the numbers that you're specifically looking for in all likelihood.
Yeah, it reminds me of Jesse when he said there's 3 coplanar points, because you could take the apex of LIGO and the ends of LIGO, and you would have 3 points. That's what you need to establish a plane, and that is the straightest thing in the universe. And they're shooting that horizontal beam out, bouncing off perpendicular vertical mirrors. So what you have there is a horizontal plane.
What you have there is a tangent plane, a plane that is tangent to the Earth at one point. The question is, where is that one point? Is it along one of those arms?
Wouldn't that be horizontal, though? Wouldn't that be horizontal, that plane, like Cleary just said?
Not the way you guys want to define horizontal, no.
How do we define horizontal as being perpendicular to vertical?
Well, horizontal at a point would be perpendicular to vertical. That's right. If you move over 3 feet, it's different. And if you move over 3 more feet, it's different again.
You know, the mirrors are pendular, though.
They're all those points will be different.
All the pendular are all hanging vertically, the mirrors.
Yeah, I'm sure they are.
So that would be perpendicular to horizontal. At 5 points, because there's 5 mirrors, isn't there? So that's 2 more than Cleary. How's that for you? Is that all right for you, Cleary? It'd be 3 points along each arm, wouldn't it? All of the points, actually, all 5 points would be defining the same horizontal plane.
Not horizontal plane, tangent plane.
Tangent to what?
Tangent to the Earth at one point.
You did hear him say the mirrors were hanging.
It is a plane in space tangent to the Earth at one point. It can only be tangent at one point.
So are the
you
mirrors?
Guys don't even have a tangent.
Are the mirrors leaning? Are they hanging vertically?
I don't know. I thought we were talking about the arms.
Well, the mirrors are in the arms.
Yeah.
The arms and the it's mainly the mirrors and the lasers that it's all constructed around, right? They're the only pertinent things that they're trying to do. It's just the laser and the mirrors.
Yeah, I really do appreciate your candor, Blue Marble Science, in admitting that those mirrors are all vertical, perpendicular to that laser beam, which is horizontal. That would indicate that none of those verticals are tilting away, correct?
I don't know enough about the details of the mirror system to be able to even answer the question, to be honest with you.
I can tell you, Blue. What would you like to know?
Oh, please educate me, SE. You're clearly smarter than I am. Go ahead.
No, I didn't say that, Blue. I just said I have some knowledge on the mirror system because I looked into it. That's all I said.
Okay.
I didn't say I was smarter than you, Blue. Come on now.
I haven't looked into it, so if you've looked into it at all, you know more about it than I do.
Yeah, that's the only reason, because I looked into it and you haven't. That's it.
You're our boy, Blue. You're our boy.
Check this out, Blue. Did you hear me talk about it before? Because I did. If you did, I won't repeat myself.
SE,
No, I didn't.
You got images in live chat there if you need them.
Check this out, Blue. You're gonna appreciate. It's a work of marvel. It's like marvelous. There's a mirror at the bottom, 40 kilograms, about 90 pounds, perfectly polished. Now it's suspended 4 ways. First, they had it in wire, right? There's a pendulum and another pendulum and another one, 4-way apparatus. First, they had wires. There it is. He just posted it. Thank you. And they found out that it had too much noise. So what they did was they invented a system where they used glass fiber. They found out it cancels most of the noise. And they suspended it in glass fiber strings that are thinner than a human hair to achieve that accuracy. It's a thing. You, Blue, I know you would marvel at this thing. That's how accurate and precise this thing is.
Yeah, it's interesting looking.
So now imagine this now. That thing is in a tube, right? Suspended, 4 kilometers. There's one on either end of the tube, and they have to align them. I believe the woman said a nano radiant. Are you familiar with that term?
Yeah. And
I wasn't. I had to go look it up. That's pretty
nano
accurate.
is 10 to the minus 9th. Nano is 10 to the minus 9th. 10 to the minus 9th radians, and a radian is about 57 degrees. There are 2 pi radians in a circle. 2 pi radians is 360 degrees.
Yep. Now this is like 20 times a nanoradiant accuracy. I knew you would know what a nanoradian was. So that's what we're looking at here, Blue. This is the kind of accuracy level we're looking at.
Wouldn't a nanoradian depend upon the size of the radius of the circle that you're dealing with, though, Blue? What would you imagine the circle would be?
Well, you really should know this. The radian is by definition is 360 divided by 2 pi. By definition, that is a radian. There are 2 pi radians in a circle.
Yeah, but how big's the circle?
Doesn't matter how big or little the circle is. Doesn't matter how big it is. How many degrees are in a circle? How big is a circle? It's the same question. Radian is just another way of measuring an angle.
Yeah, but it's an angle around the arc of the circumference of the circle, isn't it?
It's an angle. It's
not the angle's the angle. The radian is the measurement of a radius around the circumference. But you have to know the size of the radius of said circle to know how big the radian is, don't you?
No, you don't. Not at all. That's like saying you have to know how big the circle is to know how big a degree is.
You know how big a degree is.
Well, then you know how big a radian is, too. A radian is 57 degrees, 57 in choice, and change, whatever that number is.
So it's basically just an angle then, right?
I forget. It's a substitute for angle if you think about it, you want to think about it that way, that's actually what it is. It would be, let's see.
It kind of is like that because, like the woman was explaining it, the way they align those beams, those mirrors, they use the beam actually, and they use the beam pattern. Yeah, they use the beam pattern to knock off the dead areas, and once they got the full spectrum, they knew they achieved the perfect light or whatever. In order for this apparatus to work, it has to be aligned to like 10 or 20 nanoradians.
And that's the angle hanging down. That's the pendulum hanging down. That angle is near perfectly vertical. It's just
would it,
a nanoradian
would it
off.
surprise you? Yeah, well, would it surprise you to find out that you could hang a mirror from two lines like that, two wires or whatever you want to say, and that mirror could be pointed straight up or straight down or perpendicular to the vertical at that point, could be pointed any direction.
Horizontal?
Yeah. It has to be adjustable. I don't know exactly how they go about adjusting it, but they've got to be able to adjust it to a very high degree of accuracy.
Wouldn't you imagine if you shot a laser 4 kilometers down to that mirror, it should be pretty accurate to reflect that light back. It should be vertical, perpendicular to that horizontal laser beam to get that light to come back.
Well, I'm thinking it'll be awfully close to a zero incidence angle when it strikes the mirror.
Exactly.
Whatever that happens to be. So it can be twisted sideways. It can be tilted up. You're going to have all those axes adjustable to be able to bring the beam back to the point you want it to come to.
Will it be zero?
Absolutely. Perfectly
you have
horizontal.
To be dead on. Kind of like 20 nanoradians accuracy at all times.
Across 4 kilometers.
Across 4 kilometers, either way.
Yeah.
Bouncing to the other beams in the mirror. Oh, I found out something interesting, Bev. You're gonna freak. The thing that I hope I get this right. It aligns the laser, keeps it, or it's called a horizontal something or other. But the first word in it is called horizontal. I'm sorry, I can't remember the rest of it.
Yeah, well, we said that it, in order for it to be orthogonal, two arms at 90 degrees, then those to be situated, they have to be horizontal, don't they? I mean, that's what we would say.
Completely.
In reality, like all of them, because horizontal's a straight line, right, Blue? So they're both of those arms have to be on the horizontal plane.
They have to be in, yeah. Those arms lie in the tangent plane, wherever that was established to be.
But it would be horizontal, wouldn't it?
At some point, yeah.
All of it. The horizontal is a straight horizontal plane. Yeah. It's all horizontal.
It's the straightest thing in the universe.
Hey, Blue, if I have a question. You said that those two arms would be on the same horizontal plane or the same tangential plane or whatever. Right?
Yeah.
Would either one of those
points
arms
in space define a plane, as long as they're not in line with each other, right? We know that.
So
any 3 points in space define a plane as long as they're not in line with each other.
Right. Not three collinear points, 3 coplanar points. Bam.
Yeah.
All right. So if I could just finish my question. Would either one of those arms bend?
Would they bend?
Yeah. Would they be perfectly straight or would they have a bend in them?
No, I think they've got to be perfectly straight.
Oh, okay. Thanks.
Perpendicular to the pendulums, which is horizontal.
But
there's
well,
no
the
question
pendulum
that the arms
is not necessarily perfectly horizontal, as we talked about. I mean, the mirror could be tilted any direction.
Be a nanoradian off.
It could be tilted any direction they need it to be tilted to line it up.
I thought you
let's say,
understood
for
that there was a
instance,
No, they
horizontal laser
couldn't. They
beam.
couldn't because the mirrors, Blue.
There's a horizontal laser beam
Where's
that
They
the
shoots out
couldn't
4
tilt. There
kilometers.
could be no tilt in that arm whatsoever. Not even a
I didn't say the
nano
arm.
radian.
I didn't say the arm, SE.
I know, but
Oh,
like
my
I didn't
bad.
say
simply,
the arm.
simply
making
you've
a-
got
you're making a-
the you've got the laser beam shooting out 4 kilometers horizontal. In order for it to bounce back, it needs to hit something perpendicular,
The laser.
something vertical,
All right.
come back.
You've got
Right?
the laser. Hold on. You've got the laser beam shooting center of that tube, regardless of whether that tube is horizontal or tilted up at 45 degrees. It won't make any difference. The laser beam is shooting down the center of that tube, 4 kilometers. It then has to strike normal to the surface of a mirror to return the beam back to its starting point.
Come back on
Perpendicular.
itself.
That's
Yeah,
all
but
that
if
has to
those
happen.
but Blue, if those mirrors are on a tilt and they're on a plumb, how would that work out?
I don't know the details of how they adjust it, and I'll look into it now.
Can I
Can
can I
two
just
straight
correct
lines-
you though? Sorry, you just said it bounced back normal. That's perpendicular,
Normal
isn't
simply
it?
means perpendicular. It has to strike the surface of the mirror, essentially perpendicular to the mirror. I'm assuming it's going. It can't go straight back to its source.
Okay, so if
Oh, of course
if
it
it's
could.
traveling horizontal, then the mirror being a normal surface to that laser, the laser beam is perpendicular to it, right? So if the mirror's a pendular, then the laser beam must be horizontal.
You're assuming that the laser that the mirror is suspended in such a manner that it would be it would be held in place perfectly perpendicular. And that is not necessarily true. I could tilt that mirror any way I want to,
And that
and
light
it would
is
still
going
be
to.
pendulous. It would still
You
be
wanna shoot-
pendulous. It would just be pointing some other direction.
If you want to shoot that laser out and bring it back, it would be like 2 straight lines sharing a common line segment. It would be one single beam out and back. I don't see how you could cut an angle there and arrive 4 kilometers away. That's got to be perpendicular. That's got to be vertical and horizontal. No doubt.
Well, I don't share your opinion, but you can assert that if you wish.
Why would you not agree with yourself when you know that it's got to be perpendicular?
It's a globe dictates, isn't it?
Again, I don't think anybody sitting here is doing anything other than guessing at the details of this thing.
No,
Looking at a couple.
This is
Looking at a couple of cartoons that you jerk off of
deductive reasoning.
YouTube
what we're
doesn't
doing,
necessarily
Blue.
tell the whole story about a device that complex.
Blue, I can assure you everything I told you came from one of those scientists' mouth that constructed it him or herself. You know I don't bullshit.
Right.
I knew I'd get a chuckle out of you on that one. Look, bottom line, Blue. This is the bottom line here, okay? We all agreed that this is a pretty level apparatus here, and we got guys like Kosho, George Nunchuk, and I believe, I forgot the other, a paid NASA genius, Shill, and they're saying that the arms are slightly higher at either end. I'm sure being an engineer and somebody wise like you doesn't believe that, right?
I believe there's insufficient information to just say that.
Well, for them
After
to say
us-
that, or for SE to say it, who is there insufficient information to say whatever has been said?
Nobody has sufficient information that I'm aware of. Not you guys, not me, not anybody not anybody that's been involved in this discussion has any detailed knowledge of how that thing was laid out and where the tangent point is for the tangent plane that those arms lie in. Now, you can look at the one in Louisiana if you like. And I believe it's the east-west arm of it that are essentially, that east-west arm is essentially it's the same elevation from one end to the other. But all you can measure on Google Earth, all I can do is measure the elevation of the roadway. Go ahead.
What's the east-west arm? You said east-west. Do you mean southwest or southeast? Because there's southwest and southeast.
There's an arm. It's not laid out exactly north and south. There's an arm that's running predominantly east and west, and there's an arm of it that runs more or less north and south. I think it runs from southeast to northwest, maybe. I don't know.
Well, in the documents, they refer to it as the southwest arm and the southeast arm because both of them are facing somewhat south, but one's facing more east, one's facing more west.
I really don't. Let's see.
Did you say one of the arms is at the same elevation?
Hmm?
Did you say one of the arms is at the same elevation all along?
Well, the roadway next to it is. And whether that has any, I mean, I don't know if that is indicative of how the machine itself is laid out or not.
Do you think a constant elevation is a straight line, Blue?
You can't even get necessarily good elevation data off of just Google Earth.
It's not
Certainly
Google
not
Earth.
this accurate, but think about this.
It's actual construction data. It's the drawings, the engineering drawings when they designed the place.
But in terms of elevation, Blue, do you think a straight line is a constant elevation, horizontal line?
No.
So
Would you say
measurable change from?
No, it's not a constant elevation.
What about mean sea level?
That's what I'm talking about with elevation, mean sea level.
Okay, so
if it is perfectly straight, it is not at a constant elevation. It cannot be.
So there
on
should
your
be
model.
a measurable drop to your constant
Yeah.
if it's not horizontal.
Yeah, there'll be a measurable drop.
So if you measure an
question is
8-inch
from where?
drop, if you
From
measure an
where?
8-inch drop over a mile, what is that? Earth curvature or elevation?
Yeah, of course, Earth curvature.
Wow, that changed.
Are you joking?
Of course.
We've already done that before. Well, you did say
I
one
don't
of the
know.
arms was the same elevation all the way along, didn't you?
Yeah, and if the tangent plane was established somewhere near the center of that arm, that's what you would expect.
But you just said
It's only going to be down 8 inches. 8 inches on
a
either
straight
end.
line
Less than a
can't
foot.
be the same
Less than a
elevation.
foot.
The Achilles heel is
Well,
the mirrors, Blue.
The
You said
center
you
of
looked
it,
into
the center of it, Bev, if you take the time to look at it, like I've done,
How
the
about the
center of
mirrors,
it is
Blue?
not the same elevation. It's
Hang
about
on.
a foot different in the center. On that
Wait a minute,
one,
you
on
said
that
that-
one arm.
You said you took the
West
time
or
to look
east?
at it? You didn't even know what the arms were referred to, like how they
I looked at it on
identify the
Google
arms.
Earth.
Oh, yeah.
So you
So
measured
you didn't
an
actually
8-inch
look into the
drop.
construction of it. You just looked at the Google Earth picture.
Yeah, I'm just looking at it on. I was just looking at it on Google Earth to see what it looked like.
Oh, I thought you said you looked into it, like the detailed construction of the facility.
You got CBI data or what?
CBI data.
That's who built it.
Yeah, I wanted to get back to that elevation real quick, man. You said you measure an 8-inch drop over a mile and you call that Earth curvature. Is that correct?
From a tangent point, you would expect 8 inches of drop per mile. Yeah, per mile
So
squared.
your horizontal that you use to measure from, measure an 8-inch drop from the horizontal, and you call it Earth curvature,
Yeah.
right? You should be realizing that that's an elevation change. from that horizontal. Right?
If,
Are you confused?
if you want to confuse the discussion that way, yeah, you could say that it is an elevation change from the elevation.
You said that the elevation is a constant. Say it was a constant straight line, or is it a curve?
We're talking about elevation above mean sea level, which is more or
Yeah,
less
like-
in Louisiana is more or less 62 feet.
Yeah, we're talking about elevation,
About
right?
where
Elevation changes. Like Ligo is
All
a
right, so 62 feet of elevation is 62 feet of elevation. I don't care where you are.
right.
Still, it's the same elevation above mean sea level.
That's correct. Based on horizontal measurements.
The LIGO arm elevation will differ from that.
Oh, it will. I thought you said earlier that would be the same elevation all along the Ligo arm.
Well, if I did, I didn't mean to. Not what I meant.
So it was curved and now it's straight, or Ligo straight now because it was curved before.
I didn't say LIGO was curved.
Oh, when you said it was a constant elevation,
The
you
arm
call
is
that a
straight.
curve.
The arms are straight. The tube runs in a perfectly straight line.
At an even
It
elevation.
is not curved. It is not curved.
And no grade.
According to George, Paidnasa Schill, and Kosho, it goes up at either end.
Yeah,
I know you don't agree with
there's
that.
no grade, right, Blue?
Do you think that it can't be straight, perfectly straight, and not go up at one end?
No, that's
Both
what I was
ends.
saying.
What
Is
is
there a
it?
grade to them, Blue?
Yeah, there seems to be on the north-south arm, particularly. There's about a 4-foot grade on it.
Okay. On the other arm?
Yeah.
And on both arms, then?
No, just on one.
Okay. So is the other arm then the tangent, if there's no grade on that?
I think the tangent may be up there somewhere near the center of that east-west arm.
Oh, where it goes down, is it?
Yeah, it could be. That one looks to be pretty much the same elevation all the way, elevation above mean sea level of the roadway next to that arm.
The sea level of the
is
roadway.
the same at both ends, according. Huh?
The sea level of the roadway.
The elevation of the roadway above mean sea level is the same at both ends on the east-west arm. At least on my copy of Google Earth, it shows it to be, 63 feet, I think.
So have we just found our tangent point then? The midway along one arm?
It might be. I can't guarantee that, but I mean, just if I had to guess at it, that's what I would say it probably is, but I don't know that for a fact.
Well, wouldn't that have to be if you're on a mythical ball?
Yeah, it would make sense.
Well, that's the low point then. No, it's not the low
It would
point,
make
is it? Because
sense.
the
That's
other
the
one
high
gets
point,
lower,
actually.
doesn't it? It gets down to 60 on
The
the
other
other
one
arm.
gets lower by 4 feet.
Yeah, lower, but
Yeah,
it
the other
shouldn't
arm
do
goes
that,
from
should it?
63 feet down to 50.
Shouldn't get lower, should it? If the tangent point's in the middle of the other arm, the other one shouldn't get lower, should it? Unless there's a grade.
Yeah, it absolutely should. It absolutely should.
Should get lower.
Yeah.
Is that what tangents do, Blue? Get closer to the surface the
No.
further they get away. I don't think it is. Geometrically, not anyway. Not in the geometry that I know.
Lou, I asked the question before. I don't know if you heard it or answered it. I don't think you answered it. Can we have a hump or a drop without having elevation change?
A hump and what?
Well, on the surface of, let's say, water, for example, or
Well, we don't see very many humps in the surface of water now, do we?
No, but that's not the question. The question is, can we have a hump or a drop without having elevation change?
Not to my knowledge.
Oh, so that 8 inches
talking about
measured was an elevation change then.
You talking about the terrain moving up and down, measuring the elevation of the terrain, Montreal?
Well,
how could you not have a change in elevation if you go up a hill or down in a hole? I mean,
I agree with you.
got to have an elevation
Now put
change.
yourself on the water, and I ask you the same question.
Same answer.
So you're saying no, we cannot have. Is that your answer? We cannot have We cannot have a hump or a drop without having elevation change.
In that, in sea level is sea level. I don't care where you are. In the middle of the ocean, on top of a mountain, sea level is still sea level. You're measuring an elevation above sea level.
Can I jump in
but
real
that's
quick?
not what I asked, bro. I know you realize now where I'm going with this, and you're starting to
Can I jump in?
I don't.
second guess
Can
yourself.
I jump in real quick?
Sure, bro.
When you measured that 8-inch vertical drop over that mile and you called it earth curvature, you measured an elevation change according to what you just said.
Sea level didn't change.
He
If
just
you
asked
measure
you.
it to
No, it's a mean sea level. It never changes, Blue. It's established as a mean.
I know, that's what I said. Why do you say I didn't say that? That's what I said. Mean sea level is mean sea level. It does
Why do you
not
keep
change.
going back? Why do you keep diverting to mean sea level when we're
Yeah.
talking about an elevation change? But you just said if you have a hump or a drop, you will.
Elevation. I'm not diverting. I'm not diverting. Why do you not understand that mean sea level is mean sea level and that elevation change is measured from mean sea level?
Right. You measure the elevation change. Any change in the vertical from the established horizontal would be an elevation change. And you said that if you have a drop of water or a curve of water, you would have an elevation change. But when I asked you if you measured an 8-inch drop at a mile, you said that was earth curvature. You're contradicting yourself, my friend.
I don't think so. I think you're failing to understand what I'm saying.
No, you are absolutely contradicting yourself. You've done it about 3 or 4 times here, Blue. And have they sent you put you forward to do this, or did you volunteer?
So what?
Did they put you forward to come here and be the representative, or did you volunteer?
You guys invited me.
Yeah.
You guys invited me.
Yeah.
I didn't. Nobody puts me anywhere, Bev.
Okay, isn't that nice? So you volunteered to come here then?
Nobody puts Blue to do stuff. He's a Southerner. Don't mess with Blue.
Yeah, my boy Blue.
We seem to have a problem
I
with.
believe that. I don't think anybody put him up to it.
We seem to have a misunderstanding of what elevation is here.
Now that's a problem, yeah.
Yeah.
I don't think Blue quite grasps the
I have
meaning
no
of-
misunderstanding about what elevation is.
Is it a measured change in the vertical? Would that be a change in elevation?
A measured. I want you to define for me a measured change in the vertical. What exactly are you talking about?
A measured change from mean sea level, either up or down in the vertical, like measured with when you hold a staff and you measure either up or down. You hold a staff. You know, you've seen a surveyor that stood there with a measuring staff. We'll keep it with the measuring staff because that's got numbers on it and make it easy for people to see. And they hold it there and they make sure to hold it vertical. And then if you change up or down on that scale, then you would call that measurement change a change in elevation.
Yes, you could. Yes.
Well, there you go. A change in the vertical, right? So A change in elevation is a change measured in vertical, like actually measured, not calculated, but measured.
Yes.
Okay.
Elevation is elevation.
Mm-hmm. And vertical is perpendicular to horizontal. So you have a tool called a level that sets a horizontal.
Only at one point.
And, well, it's the whole of the line that you use when you use a level. That's horizontal, isn't it? A level establishes a horizontal plane of reference that you can then measure a change in the vertical from.
You're talking about now a auto level or a theodolite or something like that?
Let's stick with an auto level, a coincidence bubble level.
Okay. Yeah, and there is that auto level is establishing a horizontal which is tangent or parallel to a tangent directly under that auto level. And that's the only place it's tangent. Only be in one spot.
No, the whole of the line that you look along would be horizontal. It's a straight line. A horizontal is a straight line, isn't it?
Straight line. Yeah, absolutely.
And
So
the verticals on that straight line are perpendicular to it.
Tangent at the point the instrument is sitting.
It's not tangent, is it? It's at an altitude, isn't it?
Well, okay, I'll clarify that again for you. It is tangent if your instrument is sitting directly over a benchmark which is at sea level. Okay, can we do that? Can we imagine that? We've got a benchmark in the ground. It is sea level. And we set our auto level up right over the top of that. And our telescope is 5 feet above that benchmark.
And where are you looking?
It is shooting a horizontal. You're shooting a horizontal line, which is parallel to the tangent line, but 5 feet above it.
No, it's just above the datum. That's it. It's just above that datum point, isn't it? And it's 5 feet above the datum point.
Give him that tangent at least. I mean, what are you looking back out across the ocean? Are you looking on the land? Or are you going to start doing different?
Doesn't matter where you're looking. Doesn't matter where you're looking. Looking horizontal from that point.
Yeah, horizontal plane.
As you measure. Go ahead.
No, I say it's a horizontal plane. You carry on. I'll find the coincidence bubble level.
Yeah, so you've got your auto level set up. You're going to start differential leveling from that datum right there at mean sea level. You're going to go up onto the land. More than likely, it's going to be higher than sea level, right? So you're going to start measuring elevation based on your horizontal line of sight, using your rod to determine vertical changes from that horizontal, which you would call an elevation change. More than likely a rise coming from the ocean edge onto the terrain, correct?
Now, what are we going to? We're going to move on to differential leveling. Is that what you're going to start talking about?
Well, we just went from the edge of the ocean up across the land. Okay, now we've reached the horizontal.
Well, we don't have to be on an ocean. We don't have to be anywhere. I mean, I'm just telling you. You're trying to answer your questions the best I can.
Yeah, so at that point,
confuse it any more than we have to.
Right. So at that point, we've reached LIGO. We're at 62 feet above mean sea level. We came down. We came from the ocean up 62 feet. All right.
Yeah.
That's the vertical elevation change based on the horizontal rise and run. The vertical and the horizontal rise and run, stair stepping our way up to that elevation of 62 feet above sea level.
Above sea level. Yeah. Okay.
Yeah. So it's a vertical change from that initial horizontal that you established at mean sea level. You've risen 62 feet from that.
It's a vertical change from that elevation. Yes.
Yep, to your new elevation, which is a new horizontal you've established. Right? So when you measure from there,
I
let's
don't
say
know
you
what
measure.
your point is.
Yeah, we're at LIGO now. We've reached LIGO. Now we measure down.
Okay, fine.
We would just measure down 1 mile, right? What are you gonna see there next to that canal, next to that straight LIGO? It's going to be horizontal.
Using an auto level, if the light, well, again, this is all about how they laid this thing out. If you're sitting at the tangent point, assuming one of those arms is the tangent point.
Yeah, you said it was you said it was an even elevation across there, based on
I said the
sea level.
roadway is all at the same elevation. That doesn't necessarily mean a damn thing when it
So
comes
you
to the
could say
machine
that the
itself.
roadway, you could say the roadway itself is horizontal.
I could say the roadway is level.
Well, if you measure any kind of drop in it, you could say it's not horizontal, but you're not going to measure any drop in it, like you said. So it's going to be an even elevation.
Well, I don't know that.
Based on that run.
How do you know that? In fact,
Well,
I would
because-
tell you that if you've got the same elevation at both ends of a 4-kilometer roadway, yes, you're going to. If you set up in the center of it, you're going to see a change. You're going to see that
an optical drop.
That drop is there.
That optical drop is there, but you never had that curve all the way from the benchmark at sea level all the way up to LIGO. You never had any curve in your rise and run. You stair stepped the whole way there. You had no curvature at all. And now that you're on a horizontal plane with horizontal water based on hydrostatic equilibrium and even altitude of pressure, now it's going to start curving.
Oh, did you differential level your way up there?
Yeah.
Do you know how to do that?
Oh yeah.
So you know you're setting up every time at the tangent, at essentially the tangent point, and you're shooting a foresight and a backside every time, correct?
Very accurate, yes.
Do you know why you're doing that?
Oh, so that you can make sure you establish a horizontal and a vertical. It's accurate. You want to overlap.
No, that's so you don't accumulate drop error.
Right. You're being accurate. You're trying to be as accurate as possible.
That's right. And you're trying not to accumulate the drop.
Which there is no drop. You're just trying to make sure your horizontal is true.
There is drop.
It's just like Euclidean geometry, right? Two straight lines. Two straight lines.
Of what you want to say, there's drop there.
No, two straight lines cannot share a common line segment. So when you do your differential leveling, like you should, where you overlap those two straight lines, they become one line segment, one horizontal line. There's no error at that point. You're looking at the ass backwards as if you're trying to include the curve in your errors, but you're actually trying to make sure that your horizontal stays true. A single line segment, not two lines that aren't straight. That's all you're doing.
And each one of those tangent points, each time you move that level, 100 yards, whatever, however far you're going to go with it, you actually have established a slightly different horizontal.
No,
it's not enough to throw you
horizontals
off.
don't intersect, Blue.
But it actually is there.
That's
over 100 yards. You're only talking about, I don't know, a few thousandths of an inch. It's not.
Whoever told you that lied to you, man. Whoever told you that lied to you.
Well,
sad.
So my model dictates, isn't it, Blue?
That's the way it works, and if it is disturbing, I'm sorry, but that's how it works.
So yeah, that the actual bubble level that's cited in the book, well, in the documents for LIGO, for the one used, is the one I've just put in the live chat. It says it establishes planes which are orthogonal to the gravity vector. What's that? Orthogonal to vertical is horizontal, right?
I don't see what are you talking about?
I've highlighted all of the pertinent bits. of the coincidence bubble level. You can fit a micrometer on it. It's like the fanciest level you'll ever see. It says it's used to measure a deviation from level, and it says that establishing planes orthogonal to the gravity vector, and it says it's good for substituting for a transit when holding a horizontal reference line. So that backs up the orthogonal bit at the beginning. And then it says a precisely level optical line of sight, which, I mean, I agree with that. Precisely level. And it says the bearings to bring the line of sight to dead level. And it says it enables you to detect the tiniest deviation from level. It says the level vial is adjusted parallel to the line of sight, and each level has telescopic adjustments which will maintain a straight line of sight through the focusing range with an optical micrometer. It's a fancy piece of kit, this.
Absolutely.
So it's straight, level, orthogonal to the gravity vector, and horizontal. All of those perfectly true, right?
Yeah, especially the part where it says it's good for establishing planes, not just one, planes which are orthogonal to the gravity vector.
Yeah, horizontal planes. Yeah, that's what they do. They don't intersect though.
Every time you move it, you'll establish a new plane orthogonal to the gravity vector at that position.
Absolutely. It'll always be orthogonal to vertical, horizontal.
But that's a different plane for each position you put this thing in.
Yeah, you know how to do differential leveling, don't you? Very rarely will you end up on the same level when you reset your equipment up. It will always be parallel to it, though, won't it? Always be parallel to the horizontal. And the tiniest deviation from level would be the adjustment in elevation.
Parallel planes.
And if you shoot that thing out there a mile, you will see an 8-inch drop.
Well, that would be an elevation change then, right? A measurable drop in the vertical. Measurable change in the vertical, sorry. Oh.
You'll read a bigger number on your story pole. Is that clear enough?
Not if the land goes up, though, surely. If the land goes up, it would get smaller, that number, wouldn't it? I mean, that's what the tool's there to measure a difference in elevation change.
Okay, to the same elevation. This thing will be shooting above it.
To the same elevation? No. That would be a change in elevation. If there's a vertical distance change, that would be what is known as a measured change in elevation.
Well, you do realize that when you look down, you don't look down a mile with an auto level and try to pretend like you're looking at vertical optical drop.
Yeah, you don't.
Right.
There's a reason you don't.
Because it's level.
You want it level, right?
Yeah, you do.
You want to establish a level. You try using this thing for a mile, you're going to be 8 inches out if you go a mile with it.
Why?
The reason we don't do that.
People
Because
don't
the Earth is
survey.
curved. That's why. Because the Earth is curved. That's why.
That's a presupposition.
No, there is
After
such a
all-
thing as a curve, right? We call that
presupposition is that it's
mountains.
flat. That's called, when you say the Earth is flat, that's a presupposition too now, isn't it?
Who
We
says
don't say
that?
the Earth is flat.
There's elevation changes. We know that, Blue. It's measured by the tool.
Well, we
We've just shown
understand that
that.
too. Okay. Elevation relative to mean sea level, which is the only thing we measure it to that I know of.
Yep. A mean sea level is a datum.
From
It's
a
a
hor-
zero. That's
from
your
a true
zero datum.
horizontal, it will drop. It will drop from a true horizontal.
So is it dropping as you're going up vertical as well? So are there two different vectors that are going on there? Because you're going up a hill, right? And you're having a vertical change there, but are you also going down as well?
If you're going up, that's a broken question, actually.
Yeah, well, that's the
If
model.
you're going up a hill, then the elevation of the ground you're surveying is changing, right? I'm talking about to the same elevation. Establish
the
a
horizontal.
level line.
Yeah, based on the horizontal.
Get that water level out that you're so fond of. Okay? Get your 1 mile water level. I've never seen one that long. But if you could find one, get your 1 mile water level and find the level points 1 mile apart. Now set this auto level up over one of those points,
Mhm.
and you will see an 8-inch drop to the other point.
Who's done that?
Yeah, I've never heard of that.
Who did that?
George has done it.
George what? No.
Natchik's
No,
done
he
it.
only measured refraction.
He's measured drop.
George is a surveyor.
And it comports perfectly with
Did you say George is a
the
surveyor?
8-inch per mile squared.
Has he
George a
measured? Has he
surveyor?
measured rise?
He
Is my
measured
mic work good
rise.
today? I don't even know if I'm coming through.
Yeah, can hear.
So some guy on YouTube that's not a surveyor named George measured curving water.
No, he measured
I'm
elevation
talking
drop.
about George Natchik. George Natchik's made a lot of observations up at Rainy Lake. He lives on that lake. He's made some great observations in the wintertime when the lake is frozen.
What authority does he have to provide, accurate data?
That's the same as you got, I suppose.
Well, I'm not up there making claims of curving water. He is. He's making claims of that. Who is that? Just a guy on YouTube?
And he's an engineer. He's done a lot of stuff on YouTube.
Yeah. Like
Really
made
smart
death
guy.
threats. Yeah. Had to ban him for making death threats on page over at Brandon's server. But Ranty let him back, so I wouldn't say that's a good source.
I think he
Is there
wished
anybody else who's,
death on me
measured
as
curvature?
well.
Mhm. Is there anyone else who measured
Death threat,
curving
huh?
water? Has anyone
Specifically
ever measured?
measured curving water.
Yeah.
I don't know. I haven't looked around. I'm sure many others have done it, but
What if you got to say yes or no? Would you say yes or no?
same answer. I'm sure others have done it. Many times.
So you're sure that about something you've never seen done? Absolutely sure.
Pretty darn.
What else can you say?
Say drop is a change in the vertical, right, Blue?
I don't like the way you word that, but
It's down.
drop is a difference is a difference between level and that horizontal line you're talking about.
But I'd say they're both the same. But you'd say drop is like a downward direction from the horizontal.
Yep.
Yeah, I would agree. Drop is definitely a downward direction, vertically downwards drop. That's a change in elevation. That's not constant elevation. If you're going down in a vertical direction, that's not the same elevation, Blue.
Could
It is
I
the
ask one?
same elevation. Relative to mean sea level, it's exactly the same elevation.
It's a measurable change in elevation.
Could I ask one question? How would you differentiate between elevation and curvature? Change in elevation and curvature, sorry.
Well, by definition, constant elevation, unless you sea level again, a constant elevation of sea level is implied curvature. It cannot be any other way.
So when I measure with the tool that establishes a horizontal and I measure a change in elevation, that's just a change in elevation, but I'm not following.
I'm not understanding the question either.
If you measure, like you use a tool to establish a horizontal and you measure a change in elevation with that tool, that's just a change in elevation. How would you differentiate that from curvature?
Elevation change is with respect to sea level, mean sea level. Nothing more. That's all
So how do you
is.
So how do you differentiate that with the so-called drop calculations? The curvature calculator. I mean, what's the?
As I've tried to explain, you set up level points being the same elevation, and then you can measure drop. And the easiest way that can be done is the way Natchez done it over a frozen lake, where you can absolutely establish water level, okay, with the best water level in the world, a great big damn lake. And now you can take an instrument like an auto level or a theodolite, which will give you a horizontal line, and you can see the drop from horizontal at various points, various distances to that lake level.
How far was he looking?
Up to 6 miles, I think.
But that's not what the tool's made for.
Theodolites are.
6 miles?
Well, you can go 30 miles with a theodolite. In fact, they measured Everest from 100 miles.
Not to measure vertical angles.
Not to measure vertical height, sir.
Within 18 feet. And they did that back in the 1800s.
Not
The
for
restriction
vertical
on the
elevation
distance
change.
that you go with these instruments is peculiar to these auto levels. You never want to take an auto level and try to level something out more than 100 yards or so.
Yeah, that's
I
because
He's
just don't
measuring
wanna do
6
that.
miles over.
That's-
He's 12 foot above ice, and he's measuring 6 miles. You're
Yeah,
way
it's
off.
because Blue, you want first order measurement, don't you? You want to stick to the highest order of measurements, so you don't measure over massive distances like that.
Yeah, if you measure over massive distances like that, you will not be level. Drop will get you.
What? Drop will get you. No, you're after first order measurements, well, especially when you're dealing with elevations, because you want to make sure, especially for flood reasons, you don't start building in places where you're going to end up flooding. You want to try and keep that flood and the dip and all of that to minimums, don't you? So that's why you stick to short distances, because the optical range of those things aren't accurate to the millimeter range over those sort of distances. You can't measure. How accurate can you measure over 6 miles?
An arc second.
And what's an arc second over 6 miles?
I don't know. Can you do the calculations?
No, I wouldn't do the calculations, because it's not first order measurement. It's not going to be anywhere near a millimeter, is it?
Well, I don't think so.
That's why that tool that I just showed you a bit earlier, the one that they used, the most accurate level, that's why they use that one, because it is the most accurate level for doing that job. Coincidence bubble level with the highest order of accuracy. It's got a micrometer on it.
Well, I'm not familiar with the instrument. This one.
I'll get you the stats, then you can have a look at it.
Are you looking at the? We're not looking at the vessel.
No. This is just the coincidence bubble level that they said they used.
Hmm. Yeah.
Is this an auto level?
It's a coincidence bubble level. Read up on it. That's the one cited in the LIGO layout plans to aid
when you're
the GPS.
When you're holding that horizontal reference line for a distance. So accurate.
And they didn't even try. Well, I mean, I think they should have used the communicating vessels, but I guess you think they. Well, I mean, that is a level that establishes a horizontal plane. It says it's ultra accurate.
Oh yeah, no doubt.
Yeah,
Yeah.
It does.
So that level is a horizontal plane, right?
Horizontal, yeah. You can swing it through a horizontal plane.
Yep. And it's a level, and it like they don't seem to make any differentiation between horizontal plane and level. It's almost as though they think, the guys that make those tools, the ultra accurate ones, don't know the difference between them, because I guess they think, like me, level is horizontal. It's the same thing.
No, I don't think they think that at all. I think they know much better than that. In fact, I would bet on it.
Thinking what someone thinks.
Why don't you call them up and ask them?
I don't need to call them up and ask them. They've got it wrote there in the specifications, Blue. I'm not the one that needs to call them up. I think you should call them up and make sure.
I'll do it myself. Yeah, I think I'll do it myself.
Does say orthogonal to the gravity vector, right?
Yeah.
I think that's a great idea. Let me call these guys. Give me the rest of the information on this
I'll
thing.
give it to you.
Let me call these guys up. Let me talk to I'll talk to somebody in
Brunson.
their engineering
It's
department.
in America.
I'll record it. Great.
Yeah.
If your standard for proof is trying to surmise what someone else thinks, that's pretty low criteria.
Well, I believe that's what Bev was doing.
No, the tool is described by its accuracy, what it does. It's not what someone thinks. It is what the tool does. What it's used for. Do you deny that technology?
I'm denying anything. This thing does exactly what it's supposed to do.
Right. It's not what someone thinks it does. It does what it does. And they did what they did. They established a horizontal all the way down. All the way. Straight line. Straightest thing in the universe. And it's horizontal.
You talking about LIGO now? What?
Yeah.
Yeah, that tube is straight. Within a couple of millimeters, I think, was the tolerance. It's listed, and I believe in that document somewhere.
Yeah, level is a straight line on a horizontal plane.
Nope.
Yeah. That's what it is. Geometrically. That's what LIGO is. It's level is a straight line on a horizontal plane.
Well, sorry about that, but the Earth is a sphere, no matter what you like or don't like. And
there's even a canal next to it.
LIGO's definitely straight. There's no question about that.
Definitely horizontal.
And
aren't all tangents to a radius horizontal? Or aren't they perpendicular to that radius vertical? Right? To be perpendicular to that vertical tangent point. Are you still there?
horizontals are perpendicular to the gravity vector.
So if you're saying that LIGO is tangent to your imaginary circle, it would be horizontal because it's perpendicular to vertical.
At one point, and only one point.
Well, if it's a straight line, how could it ever deviate away when it's at an even elevation, like you said?
LIGO, the LIGO arms, the 3 points, the 3 points you need, lie in a plane, and that is a plane that is tangent. Would you agree?
Horizontal. It's a horizontal plane.
That a plane. Would you agree that a plane can only be tangent to a sphere at one point, or not?
Yeah, exactly. It is a horizontal plane. Absolutely. It's a triangle. It's 180 degrees. Yeah.
Yep.
It's horizontal.
And it's tangent to a sphere only at one point.
On your model?
And only one point. Yeah.
Yeah, where is that tangent point since it's tangent across the entire plane? That's not a point that has no part.
But it isn't.
Can you prove that?
It's tangent at one point.
Can you find that point?
It's on the drawing someplace or the other.
You can't find it. You couldn't find it the other day. You can't find it now. You will never find it because that tangent point, my friend, does not exist.
Well, let's see. A global coordinate system denoted by subscript G, specific to each LIGO site, was defined, in which X sub G and Y sub G are aligned along the interferometer arms, and Z sub G is normal to these axes. The interferometer plane was chosen. The interferometer plane was chosen to minimize construction costs, such that the global coordinate system lies in a plane that is locally tangent the WGS-84 model at some point within the triangle defined by the 4-kilometer arm.
There you go. Your model.
Now that's straight
right?
out of
tangent to a model.
straight out of the documentation. That's straight out of the documentation.
That's a flat spot
provided by Caltech.
That's a flat spot on your ball where all of the things you pretend exist on your ball don't exist on that horizontal plane where the water is horizontal and LIGO is horizontal and it's straight. Is that what you're saying?
Saying what I'm saying exactly what the Caltech documentation says.
The water doesn't curve. Water doesn't curve right there. Horizontals are always perpendicular to vertical all across that area.
And
Everybody,
vertical.
can you hear me?
Yeah, go ahead, Brian.
Just saying hello. I'll come in a second. Sorry.
Vertical is different at every point on that site. Not by much, but it will be a little bit different.
Well, wait a minute. Now you're seeing it curves?
The gravity vector is not the same at any 2 points. Again, you don't have to like it, but that's the way it is.
The vector's not vertical. The gravity vector is vertical, isn't it? If you put in a vector
Gravity
to it,
vector is what we call vertical,
right?
And it is different at every point on the Earth.
Well, vertical's different. Vertical's always vertical. How
No,
would you
gravity.
differentiate between a vertical and a different vertical? What's that?
No.
It just means it's different. It's in a different place.
Yeah, no two gravity vectors. No two gravity vectors are parallel to each other.
Oh,
none of them.
Sweet. So they are always
all
perpendicular, though, right? They're always
That's incorrect.
Perpendicular. The straight lines are always perpendicular.
Straight lines are always perpendicular to what?
To the straight line, right? The very fact that they are a straight line means that they are perpendicular.
It's not that hard. It really isn't that hard.
Okay.
You know, I don't think you have an answer for him, so you're just obfuscating now.
Blue.
I don't know what. I don't even know what the question is. What do you? Straight lines are perpendicular.
Yeah. Well, we've got we do have a book of proofs, right? And there are proofs that perpendiculars to a plane will always be parallel.
Perpendiculars to a plane are always parallel. Yes. Okay. I'll go along with that.
Okay. Well, if you've got a horizontal plane, then what would you call all the perpendiculars to that horizontal plane?
Perpendicular to that plane.
Yeah. Horizontal perpendicular to horizontal would be vertical, wouldn't it?
And one and only one of them is the gravity vector.
He needs the 7, Bev. He needs that.
He can't.
Fundamental baseline.
I can shed some light on this. Blue, you know the zenith, the center of that tangent plane.
Center of the tangent plane, not necessarily. I don't know what you're talking about exactly, Brian.
He's meaning
that's what you've just been speaking about. You've just been speaking about the zeniths to the center of tangent planes.
Well, I didn't say zenith, and
he means the tangent point, and he means the following vertical at that tangent point that you're talking about, Blue, just to put it in your terms.
The zenith is the zenith to the center of the tangent plane. That is just pre-assumed to go to the center of an oblate spheroid model. So the next tangent plane to the front of that, or behind it, or at either corner, or at the sides of that, the zeniths to the center of those tangent planes will be pre-assumed to go to the center of an oblate spheroid model also. So because they're pre-assumed to do this, what happens is mathematically all the zeniths mathematically diverge, but in reality, they're all parallel.
Well, in reality, we never measure them parallel. Every time reverse zenith angles are measured, you end up with more than 180
Who's
degrees.
measured them, Blue? No, wait a minute, Bright, please. Who's measured them, Blue? Who's measured verticals not being parallel?
Reverse zenith angles, I think probably every surveyor, every actual legitimate surveyor.
Give us a name, Blue, please, and then we can check up that they've done it. Because everyone that I've asked has said no, they have never measured verticals being not parallel. Now, who are you citing?
Jesse Kozlowski.
Pardon?
Okay, Jesse Kozlowski.
Jesse Kozlowski hasn't done that.
Larry.
Has Larry done that? We'll have to ask Larry about that next time.
Yeah, Larry's done it.
Got a few questions to ask.
I think every surveyor probably has done reverse zenith angles.
So it's Jesse and Larry
Could
only,
you bring us through
not
the
everybody.
process of reverse zenith angles, please?
2 YouTube surveyors.
Well,
no,
Larry isn't a surveyor, is he?
YouTube. He's like an actor on YouTube.
Really?
He plays a surveyor.
Are you claiming to be one yourself?
I've got surveying qualifications, yeah.
Do you have a license? Larry has a license.
No, I don't have a license.
Well,
I'm not in America.
Oh, they don't require licenses where you are then? Okay.
No,
So two guys on YouTube.
Not for me
told
to
you
get
that
my
they can measure,
qualification, no.
Yeah, 2 different guys on YouTube told you that they could measure plumb bobs deviating from one another. Just 2 guys on YouTube told you that. No real surveyors in the real world.
I would like to hear the process of this reverse zenith angle measurement. I would like to hear the process from step 1. If you could care to give us that, Lou.
I didn't understand what you said, Brian. Do what now?
What is the technique?
I would like to hear the process of the reverse zenith angle measurement that you just spoke about. I'd like to hear the process from step 1 onward. Step 1, step 2, step 3, etc. I'd like to hear the whole process.
Well, you seem to know a lot about it. Would you like to enlighten me?
No, I didn't make a claim that it was measured. You've made the claim that they measure these diverging zenith angles, and you even called it the reverse zenith angle measurement. So I want to hear about the whole process.
I think that was the reversal, Bry. That was the reversal when he reversed the question back onto you.
Nor did I claim to be a surveyor, Brian.
He doesn't know what
that's not the
technique
point.
they use, Brian.
Sorry, Clary. Sorry, step on it.
No, I did not claim to be a surveyor. I didn't claim to have ever done this myself.
Yeah, but you claimed that they measure zenith angles, diverging zenith angles, and then you even said that you even termed it as a reverse zenith angle measurement. So, what do you know about this reverse zenith angle measurement?
Well, I know you can set up two theodolites some distance apart. Okay, and it really doesn't make any difference what elevation they happen to be at. They don't have to be at the same elevation. They can be at different elevations, and you can sight to the ocular or to the instrument, if you wish, just the instrument itself, to the lens on the instrument from each one of them. Let them look at each other and measure those angles. And when you add those two together, it will be more than 180 degrees. And there are books full of these measurements.
Sorry for cutting in on you there. Sorry, leave you finish there. Sorry, I didn't mean to cut on you.
I just want to know what surveying technique that is that you're using there.
Yeah,
you're well beyond the limits of what you might think you're doing.
What I would ask about that there, Blue, is how was it verified that it's not what you're seeing is not optical? How was that verified? Who verified it wasn't optical? That something in the distance won't appear to be lower than something of the same elevation due to angular size change? Because I have evidence to the contrary of that.
Well, maybe you ought to get a book on surveying and read about it, because it's well described, I think, in the literature.
Well, I did. I read up a lot. I even did 2 presentations on surveying, and I even offered Jesse Kozlowski and Jeff, the main surveyor, debates.
Did you ever?
I even offered to debate the two of them at one time, and they said no.
Blue, did you ever get a
So-
chance to hear my question about what is that surveying technique you use to look out at a great distance like that?
What surveying technique? What are you talking about?
Yeah, what do you call that surveying technique? It's not differential leveling.
We're not talking about leveling anymore.
Are you talking about optically measuring curve, not leveling anymore?
No, now we're
are
talking.
you
Now we're
doing?
talking about being able to measure. Now we're talking about being able to measure vertical angles.
You're measuring vertical angles. What do you call that technique where you do that surveying technique?
Measuring vertical angles. What do you? I don't know what you're asking, Cleary.
He's asking you
Yeah,
what it's
what do you-
called when you do
Yeah.
that. What is the method called?
Oh hell, I'm not. I told you I'm not a surveyor.
So you're
Don't
speaking
claim to
about
be.
something that you don't even know what it's called. You don't even know
Just
what
like
the
you are.
technique is. No, I know
Well,
what it is.
tell me what
I know
the
what it's
technique is,
trying
then,
to
Cleary.
be.
What,
I know what it's trying to be,
what do
but
you?
it's not.
What are you referring to?
It's beyond the limitations of reciprocal leveling. It's
Okay,
tool
it's
abuse
beyond.
at
It's
that
called
point.
beyond the limitations of the reciprocal method. Okay,
Way
good.
beyond.
I'll look
way,
that up.
way
Thank
beyond.
you.
Yeah,
Thank you.
way beyond that technique. And you're trying to measure vertical angles based on perspective drop and refractive effects.
Theodolites.
And the only two people that have ever done that are, well, is it 2 or 3 of them on the internet? No real surveyors do that.
Really? You know
Yep.
all the real surveyors do?
I know what they don't do.
You know my uncle. Do you know my uncle and two of my cousins?
I don't
I'll have to ask
know.
them about you.
Do they know me?
You know
They
all
probably
of
watch
these
my
people.
show. I have a lot of fans.
You're the one who claimed. It was his claim that he knew all of them. All surveyors do reciprocal zenith angle measurements. That
He
was your
just
claim.
said he knows all of them.
You
Rocky.
said you knew all of them did it.
Is that it? You're going to try to get a victory today on a word all?
All right, you guys are just
Blue,
trying to play gotcha with
what
me
you were
now. So
talking about earlier.
I'll be
you were talking
quiet
about
now.
earlier.
Huh?
when
Thanks
it came
for
to- Sorry, 1 second, Blue. Just to let you know before you go that what you were talking about earlier concerning diverging zenith angles, how that's done is they take all of the data that they record with the total stations, and they record all of that into 2D polar and Cartesian and 3D Cartesian, which is all flat plane coordinates. And then when they take all of that, what they do then is they then convert it mathematically afterwards. So there is no measurements of any, it's all mathematical. There is no actual measurements of diverging zenith angles. And I would put my house on it that there's not one surveyor that would actually put their house on being able to measure diverging zenith angles anywhere, ever.
is that it?
Yeah, ask your cousins and your uncle or whoever that you know that are surveyors. Ask them about how they measure divergent zenith angles, because they surely will be able, even if they can maybe come in and talk to Bevan the lads. You know, they'll surely be able to support this, won't they?
Well, I would think that they've got a lot better things to do than talk to you guys.
But you don't, right?
They could fill you in about it.
Well, I'm retired, Rocky. I really don't. I'm retired. I really don't have anything else to do other than just come in here and with you guys. That's all.
That's pretty sad. I thought you were going.
Well, a lot
No,
of people
not really.
say.
If that's what you like doing. What brings you here?
There's a lot of people that say they have better things to be doing, or professional people have better things to be doing, but that's not what we tend to run into. What we tend to run into is the people who won't come and talk to us are the people who are professionals but don't want to answer particular questions because they can't. There's no surveyor who can do what you're just saying. Can't. It's mathematical only. I know about it.
Oh, I think you're wrong about that, Brian. I
Well,
think we
your
can show
evidence-
that pretty easily, but
Well, you're welcome to speak to your cousins or whoever you know. I'm sure you know a few people. You're an engineer, I think, are you? You surely know surveyors. And surely one of them can tell you, put you through the whole process, and we can then duplicate this process. Bevan, lads, we can all duplicate this. I'm willing to. I'll rent.
And you've done this, right, Brian? Brian, you've done this, right?
I what? Measured diverging zenith angles. No.
Yeah, you've done it,
Can't be
right?
done. It's impossible.
Have you surveyed it all, Brian?
I know a bit about it. Yeah. But I have not
Well, I know
surveyed.
a
I
bit
don't
about
have
it
a
too,
survey
Brian.
license
But
or anything like that. But I have learned about surveying. But what has that got to do with what I'm saying?
I'm just asking the same kind of questions you're asking me. You want to take shots at my
But
family? Fine.
I didn't take a shot at your family. You
So
said
you
that
brought
your
your uncle
family
and your
were
cousin up,
surveyors.
and that's all he's referring to is the people you know.
He's
That you brought
looking
up.
for a way. He's just looking for a way out. Let him go.
All of the major.
Blue, come on. We've
Well,
had a
I'd like
nice
to
talk
talk
here. I
about mean
appreciate your
sea level. If
honesty.
he's willing to talk about mean sea level with me, it's up to him. If he doesn't want to do that now, we can talk another time. I heard you speak about that earlier.
He said go talk to the He said go talk to the experts, come back and tell us how we can duplicate it so we can go duplicate it. And then you went on to, oh, don't talk about my family. You're ridiculous, bud. Just leave, man. See you later.
Cool it, man. Why don't you guys get your thoughts together? I need to take a quick trip to the bathroom, and I'll be right back.
Yeah, that's cool. We're gonna be here.
Yeah, I don't know
They
if you
can't
guys
help
want
it,
to.
right? Can't help it. They always talk bad. Like, we need to get our thoughts together. Like, we're the dumb ones. He's going to go to the bathroom. When he comes back, we can, maybe come up with a good thought.
Maybe he won't be full of crap when he comes back.
Yeah.
Nice one.
That's a little raw. Sorry about that, audience out there.
Yeah, I might have gotten that blender figured out a little bit. I had to rebuild everything, but it's in the. I'm sharing it.
You got something in
right
live
now.
chat?
Yeah. Or no, in the. There you go. So, are you seeing
I
it?
don't know where you put it, man.
No, it's.
He's
I'm
live.
live.
Oh, you're live.
I'm live.
All right.
So yeah, I don't know if so. This is like that sphere, right? The sphere is, if you see over here, the dimensions, 127 meters, X, Y, and Z. So that would be a radius of, scaled, a radius of 6,371,000 meters. Then if I zoom in, zoom. Hey, there's LIGO.
Oh, nice.
So these pillars on the outside are vertical to the grid, which is not spherical. So anyway, let's see if I can get
At least squares, do you reckon?
Yeah, they're squares.
Yeah, but that's what when they talk about least squares on the on their transformation thing, they make a square as small as possible, or normally what they call a plane, and then that's the square that they talk about. So that's the square that you've got on there.
Yeah.
Yep.
So if I want to move it, wait, where is it? I want to move it to, say, oh, I should parent all those things. Never mind. Hold on one second. All right, so if I want to move that, oh, what happened? Oh, I parented the whole thing. There we go. Good yet? Yeah, there we go. So I want to move the whole thing to another tangent point. So this would be the tangent point. Move my cursor right here.
That's in the middle of one arm now.
It's in the middle of one arm.
Yeah.
Ish. Now it's in the middle of this one over here, and this one drops away.
Yeah. Only one tangent point allowed.
So this
It's nice to have a scale model to look at. Maybe it really is cool.
Yeah.
You're the only one who has a scale model I've seen lately.
So yeah, I mean, if you zoom out, here we go. It's pretty crazy. This cursor right here is where the tangent point is, and it's flat over here, and it goes down away from it on that side, like that. But these arms aren't going to the center of this sphere. They're just vertical according to the grid.
Yeah, well, they are perpendicular, aren't they, to the orthogonal base?
Mm-hmm.
Yeah.
Yeah. So, because, I mean, like, what the thing that gets me is when they say tangent, right, the arms are orthogonal and the mirrors are perpendicular to the beam that is going down the orthogonal straight line. So I'd say they all work. Now, the only way you can actually have a tangent is to imagine there's some sort of a curve touching one of those lines, right? Because that's what a tangent is a straight line touching a curve at one point and one point only. If it's not touching a curve, then it's just a straight line. It's not a tangent. It stops being a tangent the moment it is not touching a curve.
I thought we straightened that out to begin with. That's right. It's only tangent at one point on a sphere.
Right,
and
but
it's not a
it's all built
line.
on land.
We're not talking about
it's all built on land.
I'm talking about a
so
tangent
what's it tangent
line.
to?
We're talking about a tangent plane, not a line.
It's a plane. Then.
A
plane is
defined
only
by 3
tangent at
points
one
in
point,
space.
but that is all
plane
touching
can
the
only be
land
tangent at
underneath
one
it. Where's the tangent, or what's it tangent to?
Tangent. It's tangent to the Earth.
No, it's touching the
It's
Earth.
tangent
It's
to
all
the,
of
to
it
the
is touching the
WGS-84.
Earth, isn't it?
It's
It's
tangent
built.
to the
It's built
WGS-84.
on the Earth.
No, it's not all
Earth, the
tangent.
dirt. It is.
Plane.
Actually, not
plane.
tangent. None of the documentation says that it's tangent to the WGS 84.
Yes, it does. I just read it to you.
Show it.
I just read it to you.
Oh, I didn't.
Bottom of page
I wasn't
8 of
listening.
the document.
I'm asking for it right now. You can't provide it right now. I got to kind of go back in time or something, or what?
Provide it right. I can provide it right now. The interferometer plane was chosen to minimize construction costs determined by the local topography, such that the global coordinate system lies in a plane that is locally tangent to the WGS-84 model at some point within the triangle defined by the 4-kilometer arms. Bottom of page 8.
Bottom of page 8 of what?
It's a different PDF. It's the PDF. I think it's 06. You might have seen it. It's not that one that you've got. You've got like the full spec.
Hold on. I'll give you the link again.
Were there multiple contractors engineering the design of this thing, or what?
Oh yeah.
Oh, there were.
Yeah,
CBI was the main one.
If GPS is involved, it is all tangent planes to the WGS-84. The zenith to the center of that tangent plane is going through the tangent, basically the tangent plane, and that is the point where that tangent plane is theoretically touching the oblate spheroid model.
Yeah, he doesn't know where that is though.
It's at the center. That's where it has to be. I know what you mean, but it doesn't know where it is as far as the LIGO goes.
You mean on
There's
the apex?
Jet. I'm sure if you get back into the CBI construction drawings at some point in there, it was defined.
You know,
I don't have access to all of that stuff.
Everything I saw said the NAVD 88, not the WGS 84. But whatever.
Yeah, you were going off the proper specifications and the plans.
Be the North American vertical datum of 1988.
Yeah,
that would be your elevation,
which has been revised since then.
Well, what I'm quoting from is a joint paper written by the LIGO laboratory at Caltech, Stanford Linear Accelerator Center in Menlo Park, CB&I Services out of Plainville, Illinois, Jacobs Engineering out of Livermore, California, and the LIGO laboratory at MIT, Cambridge. That's a fairly impressive list.
Mm-hmm.
And that's their documentation on alignment of LIGO.
You want to carry on with your thing, Mobius?
I was just gonna say that would necessarily mean that these at these three locations of the vertical pillars, they would necessarily be leaning away from the center of the of either tube.
Yeah, that's the model, isn't it?
Even if there was an imaginary tangent in the middle of what you would create a triangle there, every one of those would be tilting away.
I put the tangent in the middle of one of the arms, so that would either way. Yeah, it doesn't matter where you put that tangent, whether it's at the apex, at the end of one of the arms, or anywhere.
Anywhere within that triangle.
All three of those coplanar points where the verticals would be parallel would have to lean away. But they don't.
Why?
Well,
how do you know that?
They're pendicles.
Mm-hmm.
How do you know that? Again,
because the mirrors are pendular. The mirrors are hanging
we have to
vertically.
go through that doesn't mean anything.
I must have missed all this, Lou. Sorry. I don't remember you going through any of it.
Those mirrors could be suspended like pendulum, like a pendulum, and be pointing straight up. They don't have to be parallel or perpendicular to anything
to deflect
necessary.
away from the vertical.
Let me ask
not
you.
Deflecting.
Let me ask you, Blue. Hypothetically, let me ask you then. Hypothetically, then, could those mirrors be positioned in a way to where that particular structure does not necessarily have to be the way it is on that picture there?
I would assume that they've designed
Blue,
that system.
you're assuming stuff. Like, who are you speaking for here, Blue, or are you just speaking for your model?
Bev, do you want to ask you want to ask these hypothetical questions, and then you don't want me to assume anything?
Yeah, to be fair, it was a hypothetical. I was just wondering if the mirrors
I did not
could be
representing that I designed LIGO or had anything to do with the construction of LIGO. I said nothing of the sort.
Yeah, I was just asking your opinion, Blue, on what you
that sort of stuff.
You can calm
He's
down.
asking
I'm just
me
trying
an
to get
opinion.
you.
I'll give you an opinion if that's what you want. If you don't, then don't ask me.
Well, when you're done having your fit, go ahead and answer.
not if Bev is going to attack me like that. No, I'm not
Wasn't
answering.
an attack, Blue.
Ask another question.
Okay, so hypothetically, if those mirrors could be positioned any which way, would those arms necessarily have to be perfectly straight?
Just a quickie tonight.
Or could they
so Ranty's put up a video.
hypothetically be curved over an ellipsoid and still operate?
I don't think. I don't know what the proper answer to that would be.
Well, I mean, you're a smart guy. I
Ken,
figured if the mirrors could be, if the position of the mirrors is not critical to be vertical, and you say that they can be positioned any which way, I'm wondering, asking you, if they are positioned any which way, which you're saying that they aren't perfectly vertical, right? Because the center of gravity would be different for those all three coplanar points of where those mirrors are pendicle or pendular. Then the position of the mirror, if it can be positioned any which way, then why would it be necessary for the arms to be perfectly straight?
Because light travels straight.
Okay.
Well, I don't.
I'm talking about the mirrors, not the light. Just so
Yes, but
whoever
the light
that was.
in between the mirrors still would travel in a straight line if the tube is evacuated. Right. So
I think
even if it,
I'm sorry.
even if
Hold
the
on,
light ray
Morty.
does
Wait
not,
a minute. Didn't we
Hold on a
establish
second.
that
it
the
does not
mirrors...
travel on a horizontal or on a.
We're not talking about
or
light
on a
traveling
level,
on a horizontal
still-
or anything like
would
that. You
still
said
have
it
travel
travels
in a
straight.
line. It would
Morty,
still travel in a straight line.
you said that the light travels straight. That's fine. We're talking about the mirrors.
Mute him
Yes.
if you need to, guys. You're
But
all mad.
you know, you're asking about if the mirrors can be positioned any which way. Then could the tubes be curved? Could the cubes be curved? But what determines the if the tubes can be straight or should be curved is the beam.
Mhm.
If it travels straight or not the position of the mirror.
If the mirrors have to be perfectly aligned to where they're bouncing the laser back and forth, I don't care if it's horizontal, vertical, any slant, otherwise. If the mirrors have to be positioned to where they're perfectly parallel, and they can be positioned any which way, then would it be necessary for the arms, the beam tube, to be perfectly straight?
Yes.
It would be. That's your answer?
Not because the
If the beam tubes are perfectly straight and they're not conforming to the surface of the mean sea level, then the ends, the mirrors, aren't perfectly parallel. If it's
and
if
what
it's a
makes you
sphere,
say they're not aligned perfectly parallel?
they have to be, right?
Yeah, obviously they have to be aligned
Okay.
they have to be aligned
Okay.
so that the light beam can travel between the two mirrors.
How is that possible if the beams, if the tubes aren't conforming to a horizontal plane?
Who said
And they're
they,
and I'm sorry.
they don't need to be horizontal, the tubes. They just need to be straight.
Right, but the mirrors have to be parallel.
Yes.
Okay.
Also true.
So how do you make a triangle with beams going in two different directions, right, perpendicular to each other?
Connecting the two ends of the beams.
At a center
you
point,
would
at
have a
an
triangle.
apex, correct? There's an apex point at the center, at the corner building. Yes. Okay. So the mirrors,
I guess,
must be, right? They have to be parallel in order for the beams to work properly, right?
Well, yeah, I mean, the reflecting surfaces would have
in two different directions, perpendicular to each other. Correct?
perpendicular to each other. Yes.
Okay, so it's a right angle at the corner building. The arms are going at a right angle from that apex. Correct?
From that point, yes.
Yeah, where the beams intersect, where the magic happens, right?
Yeah.
Okay.
So
if the beams are, or if the tubes are perfectly straight and they're not conforming to the surface of Earth, they're if it's off from the surface of Earth where the center of gravity is at the center, then the mirrors at either end of the arms are not parallel because they would be tilted.
Not? They can be set to
the
why is it impossible to implement an alignment control? Motion control. Why is that impossible?
We established. Yeah, go ahead.
I just want to say one thing real quick. What you're doing there with the laser is you're establishing an X, Y, and Z axis. You're establishing Euclidean 3-space right there.
No.
Okay. Yes,
You're
you
not
are
doing that with a laser.
Yes, you are.
Not how this works.
That's all I have to say.
If the mirrors have to, if the laser goes back and forth,
you're mapping out your laser with by attributing it to axis like that. But the axis are abstractions from.
If the laser goes back and forth,
embedded in reality.
If the laser goes back and forth to a degree, the receptor picks up the signal to a degree of like what 1/50,000th of the size of a proton or some shit like that. Right? It's very minuscule, right? Those mirrors have to be perfectly parallel, not kind of parallel, right? They have to be perfectly parallel.
I'd agree with that statement.
Okay. So if they're perfectly parallel and the beams are perfectly straight and the center of gravity is at the center of a sphere where the tangent point along one of those beams is anywhere along any of those beams, the 3 points, the apex and the ends of either arm are not going to be perfectly parallel.
And why not? Why can you not set them to be parallel?
You can't have it both ways, dude. I'm sorry.
Why can't you, like, I think what you mean is that if the beams are perfectly parallel and one of them is vertical, for example, the beam splitter is vertical, right? It's like just hung.
Why would they go through the trouble of making the beams straight and not conforming to the mean sea level?
Did you notice? Do you notice that I'm talking?
Yeah, I did.
Okay, so why did you start talking while I still was?
Come on, Morty, stop crying. Say what you've got to say.
I'm not crying. I'm just asking.
All right, I'll shut up. Go ahead and see it. Go ahead and say what you got to say.
Okay.
I'm going to server meet you in a second, Morty, if you're going to be a dick.
I'm not being a dick.
I interrupted it. I did it on purpose, but go ahead. If you're going to cry about it, go ahead and continue on. I'll wait.
Okay. So what you probably need to say is, if one of them is, if, for example, the beam splitter is right.
Beam splitter?
Yeah.
Beam.
Part that splits the beam into 2 beams.
Did you drop out?
I don't know. Okay.
No, I hear you. Yeah, I hear you.
Everybody's here.
Beam splitter would be the part that splits the beam into 2 beams.
Yes, carry on.
Okay. So if that one is vertical, and the things that you just said with the center of gravity and stuff is true, then then the mirrors at the end cannot be vertical and parallel to each other, parallel to the beam splitter. That's true, right? But who said they are vertical? Like there is an alignment control system.
Right. So let me ask you a question really quick. According, and this is directly in response to what you just said. Okay. Can I ask you a question?
Sure.
Okay. So you're saying that they don't need to be, directly perpendicular to a horizontal, right? Is that what you're saying?
They would
Like
be perpendicular to a horizontal.
Right, but I mean
since the two tubes form.
Try to clarify what I'm trying to say.
Each.
Yeah. So if both mirrors are parallel, they don't necessarily need to be perpendicular to a horizontal, right? They can both be leaning in exactly. Can the beams be leaning, or I'm sorry, the mirrors? Can the mirrors be leaning in any direction as long as they are parallel?
That's my understanding. Yeah, so far.
Okay. So if the mirrors are leaning in any direction, but they're parallel, right? Why would you need to build a beam or a tube that's perfectly straight?
Because the beam is straight.
Mm-hmm.
Like just because if you reflect something with a mirror and you tilt the mirror upwards so it reflects the light upwards instead of straight ahead, then it still travels in a straight line upwards.
So it has to be straight, right?
Yeah.
Okay. So why does it have to be horizontal?
As far as my knowledge goes, and this is just me going out on a limb here, right? I don't think it has to be horizontal.
Well, they said that they built this thing horizontal.
Yes.
And that it tangents the surface of the sphere.
Mm-hmm.
Uh-huh. So why would they have to? Why would they go through all that trouble to make sure that it's horizontal and not just like flush with the ground? Why would they have to go through all that trouble if the tubes can be off from horizontal and just position the mirrors any which way to where they're perfectly parallel?
So you're suggesting it would have been easier to construct them not horizontal?
I am not saying anything would be easier or anything like that. That's completely your input right there. I did not say anything like that.
I mean, you're saying like you asked why didn't they just build it flush with the ground?
Yeah.
Which would suggest it would be easier to not care if they are horizontal or not.
I'm just asking. I'm not talking about anything easier or anything like that. I'm just asking you your opinion.
You're inferring something that you're not.
So yeah, my personal opinion is, and that's again just some guess, is that one reason would be for ease of mapping the whole system, right? That this is supposedly under and how it relates to our stuff, right? It would be easier to do it if it's horizontal. And the second is it's just had the least steps adhered to, the least additional steps after establishing an orientation of the locations they're in, right? It would have the least additional work to just build it based on one horizontal.
I'm not following that
as
at
far
all.
as my understanding goes.
Could I throw something in on this in a minute?
Yeah, I feel like I was getting right there to the point I was trying to get to, but
you'll never get there with Morty, I'll tell you.
Never.
I'm not going to step on you.
No, if you just make your point, then you will get to your point.
Yeah, I hear a lot of surveyors say that these YouTube curveyors that'll argue with you for days on Discord, because obviously they're busy surveying. But I hear a lot of these guys say that verticals are not parallel.
Mm-hmm. Yeah,
Like
that's
there are no parallel plumb lines.
Yeah.
Well, you've got plumb
Well,
bobs.
no, that's not
basically.
true. No,
You've got these.
No vertical plumb line is not what they're saying, right?
Wait, what? Sorry.
No vertical plumb lines is not what they're saying. But servers do say plumb lines are vertical, right?
Okay, I said parallel. Did I say vertical?
Yeah.
I meant parallel.
Okay, so yeah, sorry.
No two plumb lines, no two verticals are parallel, right? Because vertical is a what do you call it? A vector, right? So no two verticals are parallel. However, at LIGO, the mirrors have to be facing each other, perfectly parallel.
Mm-hmm.
And each mirror is what is it? There's like 3 different mirrors for each arm, or something like that, right? There's pendulum, which are
It's a quadruple
plumb bobs.
pendulum. Quadruple pendulum, yeah.
They're like plumb bobs, right? They're hanging, freely hanging, so that they can be vertical, and they have to be parallel in order to work properly.
Well, okay, here's the thing. I did try to look into this because I genuinely think it's interesting. And to be frank, I didn't find information saying they were at an angle, right? Explicitly, right? That they were like they were hanging them from a pendulum, and then they needed to shift it upwards or downwards, tilt it a little bit, right? While hanging from that pendulum. But I also didn't find information contradicting that. What I did find when I tried to look into it is what I did find.
Morty, are you drunk or something, Morty?
What I did find when I tried to look into this is that they do have an alignment control system built in, right? So they can shift, tilt the mirrors. That's what I do know, according to the information.
It would be absolutely unthinkable not to have a system like that. You absolutely have to have it.
Yeah, to make adjustments.
And you're only
right?
thinking about one direction. What if the thing's twisted a little bit?
Right, like to make adjustments, like minor tweaks, right? We're talking yeah, it's got to be like super dead nuts, right?
Morty, what are the tolerances of? Since you know about the mirrors, what are the tolerances of the mirrors? How tightly aligned do they have to be?
That's a broken.
It was in the range question. Of a picometer, if I remember correctly. That's what they allege.
So if I can go back to my original question to Blue, hypothetically, if the mirrors can be adjusted to be like perfectly parallel to each other, is it necessary? What? Now wait a minute. What?
Parallel to each other. What mirrors are perfectly parallel to each other?
The ones in the interferometer. The ones that are shooting a beam 4 kilometers away.
Okay, well, you got 2 mirrors that are at 90 degrees to each other. How are they parallel?
2 mirrors that are 90 degrees to each other. The ones that are facing each other?
One at each end of each arm.
Mm-hmm.
Those mirrors are.
Those aren't shooting beams at each other. There's like empty fields. Well, actually, there's like all kinds of grass and trees and shit.
Okay.
I'm talking about the ones that are in line shooting the beam. Blue, sorry, I thought you were following.
All right.
So the ones that are shooting the beam have to be perfectly parallel to each other, right? I mean, that's why they're adjustable on such a micro scale, so that they can get dead nuts perfectly parallel, because they're shooting a beam and detecting beams that are off by 50 millionth or something, 50 thousandths of the size of a proton. I mean, that's pretty accurate, right?
I explained all this before. Were these guys not listening?
I don't know.
They have to be aligned. Listen up once again. These in order for this apparatus to work, these mirrors have to be precisely aligned. 20, how did I say it? Nano something or others.
Radians.
Nano radians.
20 nano radians, okay? They have to be able to predict the movement less than the radius of a proton. A proton is inside, in the nucleus of an atom. There's a proton, right? And a neutron. Okay? Are we clear?
Yeah, that is what they're saying there is they're just giving you basically a spiel to tell you just how accurate it is.
An imaginary.
Yeah, I can't take it anymore. Like with this talk,
they could never make it. Like, I mean, they don't need to do that. They make mirrors, right, on water, right. They hang mirrors, right. They're plumb bulbs, basically, right, but have mirrors. That's basically what they are.
Yeah, that's what I'm.
In simplistic terms, right.
A reflective plumb bulb.
Yeah, and they
an adjustable.
Yeah.
It's got to be tuned.
Yeah, but
it's
in what way
one
is it adjustable?
40-kilogram mirror suspended by glass fibers less than the width of a hair of a human hair. Okay.
Yeah. It's crazy. But look, it's like this. They wouldn't go to all the bother of building these two very straight things and building them against the curvature of the Earth that they believe they're on, and then have to deal with a gravity vector, diverging mirror plumb bulbs. They wouldn't do that. Yeah. If they had diverging.
That's pretty much what I was trying to get to.
Yeah, I mean, they pretty much are demonstrating a Cartesian coordinate system, Euclidean 3-space, X, Y, and Z. That's what they're demonstrating. No matter what they say they're doing, what they're demonstrating is reality, horizontal.
Yeah.
Well, they demonstrated that when they were building it with GPS. Anyway, using any kind of GPS for demonstrating X, Y, Z, because that's what GPS uses.
Well, this is what I was getting at, is because if they were using GPS to build the thing, and they were using these mean sea levels from GPS or whatever they were getting, right? And they built this thing in contradiction to the mean sea level, right? They built it differently, right? It's not flush like you said with.
No, hang on.
What's up, Rumpus? I didn't realize Rumpus
so,
was here.
I just found.
Hold on, somebody was just going to say something. Morty, can you hold on? Brian, go ahead.
Yeah, that's not correct. Mean sea level, right? All elevations are taken off of mean sea level. Mean sea level is an average. It changes from place to place. I'm aware of that. Mean sea level might be different because our tidal systems are different. So mean sea level has absolutely nothing to do with the center of an oblate spheroid belief.
Right.
Yeah, I've just put it in the live chat. The orthometric height.
I'm not saying. I just want to say that to you, Mobius, so you know in the future that has nothing to do. One thing has nothing to do with the other.
Okay, so I just found one source talking about the what was it, about the amount of adjustment that's about the size of the adjustment that the control system is able to do, and they're saying it's plus minus 4 millirad that they're able to adjust for. And if the dimensions of the presupposed sphere, what they were allegedly basing this on, are correct, then the mirrors should deviate by 0.6 millirads, 0.63 millirads from vertical. So the adjustment of the control system is well over the range that the mirrors should deviate from vertical if this whole shear thing is true.
Wow, that was a nice. Did you just do that calculation then?
Yeah, I did double check that calculation because I actually mirrorette is not an intuitive size. Degree would be more intuitive. I did double check the degrees, the how many degrees it should deviate from vertical as well. But I did have that number in the back of my mind already because this has been a topic for a while now.
Wow.
Yeah.
So yeah, I did just double check.
So, in other words, the mirrors actually, you know what, Blue? It just dawned on me looking at this diagram here. Those mirrors do at either end of the two arms are facing each other by way of the apex mirrors that are splitting the laser. They're not two separate lasers. It's one laser going through a splitter to both and then back on a different vector to the photo detector.
That's how
it's an interferometer
works.
Yeah. You said that earlier that the two end mirrors weren't receiving the same beam of light.
No, I said they're not parallel to each other. Usually they were parallel.
They would have to be parallel.
Can you see? I'm looking at the drawing. That
I've never seen Rumpus so quiet.
They would have to.
Yeah. You're right, Mobius. They would have to be.
They have to be at 90 degree angles to each other and parallel to each other. Got it.
No. They're facing the same freaking beam of light from two different directions because it's being split. Dude.
One is, one isn't.
But what do you mean one is, one isn't? It's one beam of light that's split.
That means it's then after being split.
It means it doesn't have to be a right angle. If they're splitting it at a different angle, then it doesn't have to be it doesn't have to be a right angle. It can be any angle that they split it at. They split it at a right angle. So therefore, the two mirrors are hitting the beam of light perfectly perpendicular to the light, which means that the face of the mirror with the one laser that's being the source of the laser, they're perfectly parallel with it, or perfectly perpendicular to the laser at the source.
Yeah, it has to be because they bounce the laser back and forth, and they amplify the strength of the beam. There's a certain name for it. I forget what it is now, but that's how they do it at various stages along the tube.
Amplitude, is that what you're talking about? Maybe that's wrong. The right term.
Like they say, it makes the 4 kilometers like 100 kilometers or whatever. It amplifies the beam somehow.
Yeah, because if they made 100,000, if they made would you say 100 mile or something?
Don't quote me on the numbers, but it somehow amplifies the beam, and there's even a name for it. When you bounce a laser back and forth in a tube, it amplifies the beam, makes it stronger.
Well, they'd have major problems if they had to make those arms 20 miles long.
Oh yeah, and if they weren't exactly aligned, big problems. I told you, there's even a YouTube video about the woman. She came up with the method how to do it, and it's amazing. Like they use the laser itself to and they visualize the signal, and like some places it's not aligned, and when they get like a perfect circle, that's when they have perfect alignment. Otherwise, the whole apparatus is completely useless. Completely useless. If it goes off a fraction of a millimeter of a hair of a, you know what I'm saying? It's useless.
well, useless for its purpose.
Yeah.
If
Like,
it
let's
goes a
say,
millimeter off, I guarantee it's useless.
yeah, let's
But the
say
You mean the size of a proton? It's useless.
proton. Yeah, I don't want to get too technical, you know. I'm saying whiskers, but it's really like microscopic, beyond imaginary, like a proton. You know, in the nucleus of an atom. I mean, you know, what else do you have to say?
Wouldn't it seem a whole lot easier if they felt they were on a globe with a radius of 3,959 miles as an average, to just build it straight, build both tunnels straight, but build it in accordance with that. You know, that way they wouldn't have to worry about building the whole thing, and then having to worry about whether or not the mirrors were hanging in the correct way or not. You know, such a small thing could ruin a huge project. Why would you do that if you believed that, you know, that you were building it the opposite way from your globe? Makes no sense to me. I guarantee you, I would be very, as an investor, I would be very unhappy to hear that they were going about it in that way. Just saying.
Well, I imagine they probably got a lot of money to build it the way that they built it versus any other way.
You know, they built it twice, right?
I wouldn't doubt it.
Yeah, the first one, the mirrors were hung. Make a long story short, the mirrors were hung by wires, metal wires.
Oh, right. Yeah, that's what you're saying.
Yeah, and it was running for 8 years. I don't know if it was straight, but for 8 years they were trying to detect gravity waves. No go. So they gutted the whole thing, and that's where they came up with this quadruple pendulum mirror system. And they put it in a pressurized tube, and that was part 2. They spent, I think, 300 million to re-gut both of them. They remade them new. And like I was saying before, on the first day of detection, they detected gravity waves.
Yeah, you know, Belu designed that first system and it didn't work out because it was tilted away. So they fired his ass and redid it.
Fired.
Though there is a great deal of criticisms brought towards LIGO, especially for their first detection that allegedly made like right after they started their observation.
Kind of funny,
like, this
right?
is not
Wouldn't you
without its
say?
controversy, even within the whole within the whole circle of people that adhere to that kind of information.
What do you think of that, Morty? Do you think that those mirrors are vertical, parallel, leaning, or
I have
what?
no feasible way whatsoever to verify that, actually. Like, I could deduce it from verifying if verticals are parallel or not, but I have pointed out on the server many times that I have not personally done that yet.
I wanted to hear Rumpus. Rumpus, you don't have anything to say?
Yeah, he's been awfully quiet.
The Rumpus is here and not talking?
He's been here for a while.
Happens when he's server muted, so maybe that
Blue,
has
what's
something to do with it.
Oh, man,
there he
could be.
Right, you morons. As someone has suggested, the mirrors have the ability to be aligned and
No shit.
orientated. So therefore, they align
No
them
shit.
all in a plane, and the vertical they have is with the vertical with the central section, presumably, they decide.
No
And
shit.
So it doesn't matter about what the pillars, what the building's doing. The point is you can align the mirrors how you want to make sure they're all in a plane.
Yeah,
Really
they're all
easy.
perpendicular to the plane, aren't they? All of them. All 5 mirrors are perpendicular to the plane
That's
that
what
the
we've been
lasers
saying
are in.
all along. Have you not been listening, Rumpus?
Yes, they're all perpendicular to that. Yeah, that's true.
I guess we're all morons. We're all morons who agree with him.
Rumpus, is that it, man? You got no ammo anymore. What? Look at him. He went straight on Deafin.
Why? Did anybody mute him?
No.
No. We agreed with him.
One answer, one question. Wow.
Don't get too
One
excited.
shot, one kill.
Don't get too excited.
Your server muted him again, and he went on
Yeah,
Deafin.
I server muted
you
him.
make up shit.
No, I don't get too excited. I server muted him.
Oh.
It was on my bucket list.
I stayed right here and watched it.
Go ahead and notch that
He's
one.
useless anyways. At least with Blue, we can have a
Blue.
conversation.
Hey, Blue, you mean when his first word was "we're morons"? You mean when I server muted him when he said that?
Yeah, I would have kicked him out straight after that. But it's not my place. But I would have absolutely, if it was my server, he would have been.
He is not server muted. Blue is a liar. He likes to tell stories like that. The other day, he was deleting his own comments, trying to blame me for deleting his comment. I don't know why he does that. Are you pathological, Blue?
I didn't delete any comments. If you deleted, if something got deleted, you deleted it. And I went and checked. To see if YouTube
took a screenshot of
held
the one
those
you
comments,
deleted.
and they did not. They were
Yeah, you
not
said
there.
I'm part of Nathan Oakley
I've deleted
crew. That's
nothing.
all I could read. Yeah, okay.
I have deleted nothing.
Okay, you're innocent. I'll forgive you.
Not a thing. And if you're claiming I did, you're lying.
Now you just said Rumpus got server muted when he didn't. He muted himself.
I sat here and watched the red mic come on.
I
Maybe
turned
my
the
Discord's
server mute
broken.
off. You're the one who told me.
All I
to turn the server mute off.
saw was Rumpus's mic turn red, sir.
Okay. Whatever.
Right,
Anyways,
can I just do a little bit of geometrical check here? Because I think there's a perfect chance for us here, right? Now, can we establish that there is a horizontal plane? Because if there is a horizontal plane, then there can only be one perpendicular vertical, if any at all, because we don't know where the tangent is.
If there's only a single horizontal plane, then there can only be one perpendicular or vertical to it.
Yeah.
Yes.
Yeah, but we don't even know if that's one of the mirrors, right? Or well, maybe we do, because then we would have a chance to know. This could be the first ever direct measurement that verticals are not parallel, right? Or like we've already heard from Blue,
and wouldn't be the first.
Blue wouldn't have them being a horizontal plane, right? So we've got a choice here now. We either have them being all verticals, all the mirrors being vertical, and it not being a horizontal plane, or it being a horizontal plane and none of the verticals being parallel or perpendicular to that horizontal plane. Is that geometrically okay with you guys in your model? Because my geometric model would state that if it's horizontal plane, all of the verticals would be perpendicular to that plane.
Euclidean 3-space.
Mm-hmm.
We've already been all through this.
X, Y, Z. Because the arms are already labelled as X and Y. And then I would say all of the perpendiculars, the things would be on the Z-axis to that plane. So which ones are you going to go for? Which ones are you going to aim for yourself, you guys?
Not aiming for anything. We've already gone through all this.
No, we haven't. I'm just trying to clarify now at the minute.
The arms line a plane, define a plane that is tangent to the geoid at some point.
Three coplanar points.
Mm-hmm. Yeah, we got that. Now, is that plane horizontal? Or are the mirrors vertical?
To the tangent. Yeah. It's horizontal to the tangent point. Yes.
Wait, okay, so all of the perpendiculars to that plane will not be vertical, right?
One of them will.
One.
If you're talking about gravity now, all right.
No, I'm talking about the verticals to the horizontal, right? That's all I'm talking about. The Z axis in the X, Y, Z Cartesian.
Okay. All right. Let the arms form the X and Y axis, and all the verticals will be perpendicular to that plane.
Are you sure?
Is that what you're asking?
Check the live chat.
That's what I say, yes.
X, Y, and Z in the live chat.
Not perpendicular to the Earth or to any particular gravity vector, except the one at the point of tangency, but perpendicular to the plane.
But all those mirrors are hanging.
Actually explain it fairly well.
The mirrors are all plumb bobs.
And they're all adjustable.
Plumb bobs aren't adjustable.
Which is the mirrors can be adjustable. That doesn't. So there was no need to build it on a plane to make sure that the arms were all on a single plane.
Actually, yes, they are necessarily going to be on a single plane because
if the mirrors are adjustable.
Yeah, see, light still travels in straight lines, right? And if you're going to have two beams that intersect at one point, then that's going to define a plane, no matter what you do.
So they don't have to be on a horizontal plane. They can just be on any plane, right?
Correct.
Perfect. Thank you. And then also the mirrors being adjustable, they don't come straight, right? They're installed and then they have to adjust them to make them work, right?
Of course.
Of course.
Brilliant. Now we've established that the plane and verticals. You know, the water at the side. What do you imagine happens to that in relation to the plane we've just established? I say it's parallel. What do you say?
Mm-hmm. According to the information that they're giving, it's not.
Oh, what do you mean it's not? What?
Not parallel.
Okay.
To that arm.
So what does it do then? In relation to the plane?
I personally don't know how the two arms are oriented or where it's in.
Well, it's a 90-degree angle.
Yeah, I know that they're 90 degrees to each other, but I don't know like to which point they are horizontal. Personally, allegedly, but I would imagine that it would be the intersection point of the two beams or the splitting point.
Okay, then. Well, what happens to the water? Let's imagine that Z is where the tangent is, right? Now, what does the water do?
Allegedly, in that case, the elevation of the arms would rise by about 1.2 meters over those 4 kilometers, which would mean since level water obviously doesn't raise or drop or fall in elevation, right?
Mm-hmm.
Level water at rest doesn't raise or fall in elevation. That would mean that the water gets lower than the arm.
Okay.
Over that 4 kilometers.
Okay. What about? So that means that if you were to extend the arms in the opposite direction, they would cut into the earth, would they? Like they're on an incline.
No.
Well, the one that's dropping would, right? Or the one that's not dropping would.
If you extend, like you're now at the intersection point of the 2 beams, and you now extend one of the arms further away in the direction away from the arm. Is that what your intention is?
No. The arms are still there, aren't they?
Yeah.
Okay, so the water drops away, you say, or they rise up from the water, which...
Yes.
Is the water dropping from the horizontal plane, or is the horizontal plane rising away from the water? Which one of them is it first?
The horizontal plane has one tangent point, according to
it was a specific question.
Yeah. In relation to the water. What is the water doing in relation to the horizontal plane?
It's dropping away in every direction.
Okay. So let's go to the other end of the tube, the other end of the arm. What is the water doing in relation to that?
In relation to the arm?
Yeah.
Well, if it's dropping in one direction, then it's rising in the other, right?
So the water rises then?
Not in elevation. The water is at a constant elevation since it's at rest and level.
You said it was dropping from the arm.
Yes. The horizontal plane did not have if that information, according to that information, does not have a constant elevation. The elevation of the horizontal plane keeps increasing the further away you get from the point where you established the plane, to which you established the plane being horizontal.
Okay, so in relation to the water then, what does the horizontal plane do from the end of where the other end of the arm? I just
said it.
What, the horizontal plane gets closer to the water?
I'm not sure. Where are you? Where are you having problems?
I'm not having problems. I'm just asking you. You say from the apex,
asking the same
Morty.
Question,
Yeah, no,
which implies that you're having problems with understanding.
Morty, from the apex, you say the water always drops away from you. So the water drops away from the apex. Then let's walk down that 4-kilometer arm, and now we've got the water that is. Well, I don't know. You say it's dropped away from the horizontal, right? The plane.
It's not what I say. It's what derives from the information that you're giving.
No, I'm asking you now, Morty. I'm asking you what you just told us. It drops. Now we've walked to the other end of the horizontal plane of the arm. That happens. Now, what happens to the water when you get there?
Again, I have answered all those questions already.
Does the water drop away from the horizontal plane at the other end of the arm?
Yes, but the arm is not on the horizontal plane.
It is. We've just established it is on the horizontal plane.
You just
Morty.
cut me off. Did you notice that?
Yeah, because you were saying it wasn't a horizontal plane, but we've already established it is the horizontal plane.
You noticed that you.
If you want to cry, Morty, and stop,
in a
you
term
want to
that's
tap out,
non-divisible.
Morty.
you cut me off in a term that's non-divisible, right? That's gonna be a straw man if you cut me off.
What?
Yeah. Okay, so the arm at the other end of the arm, if it's in a horizontal plane to the point where the beam splits, right? Then the arm is not gonna be in a horizontal plane to the point at the end of the arms, right? According to that information, a horizontal plane has a different orientation if it's horizontal to a different point, to a different location.
Really?
According to what they're saying.
What they say? Who's they?
The ones that are publishing all the information about LIGO.
No, I don't think they've ever said that horizontal planes intersect. I've never read that. Have you?
That's a logical conclusion of what they're saying.
Oh, you're making a logical conclusion, are you? That geometry's broke?
No, it doesn't break geometry at all.
Mobius, can you kill your stream?
It just means that not all that vertical is location dependent, basically, and therefore horizontal as well.
Vertical is always perpendicular to horizontal, always.
Correct, by definition.
Yep. And vertical's a straight line.
Yeah, but
horizontal's a straight line.
If the spatial direction of vertical is dependent on the location that you're at, right?
And straight lines can be extended.
It's possible for verticals or horizontals for that way, for that matter, for established at different locations to intersect.
Okay, can I just check? Can I just check?
It doesn't contradict any geometry whatsoever.
Okay. Can I just check then, just to make sure? We've got a horizontal plane that goes out on the X and the Y axis all the way to the end of X and Y. Now, if we drop a plumb bob at the end of that arm, the horizontal plane, would it be perpendicular to the horizontal plane?
No.
That you're saying that a vertical, a plumb bob, isn't perpendicular to horizontal then?
Yes, because with the plumb
bob, that's why I was saying you were breaking geometry, because vertical and horizontal
I'm not breaking
are
geometry,
perpendicular.
Beth, I'm not breaking geometry because I just established that vertical could be location dependent. With a plumb bob, when you're dropping a plumb bob at the end of some line, at the end of some distance, then you're establishing the vertical over that point.
Yeah.
You
should do with any plumb bob. Yeah,
if it's location dependent, then there is no obligation for that vertical to be parallel to the vertical that where you established the horizontal.
No, that's why I said you're breaking geometry, because
this doesn't break geometry at all.
Morty, stop interrupting, please.
Vertical,
Morty, can you please stop interrupting? Vertical and horizontal, Morty, you're doing it again. Vertical and horizontal are perpendicular. That is a geometric relationship between two right lines. Do you agree with that, right? That is a geometric principle.
Correct.
Okay, now, you've just said we establish a horizontal plane. And then you've said we get a vertical and it's not perpendicular to that horizontal plane. But that breaks the rules of geometry, because vertical and horizontal are perpendicular.
Yeah, but if they are location dependent...
They're not. Vertical and horizontal are perpendicular. It's a hard and fast rule. There's no location dependency about it at all.
No part of that definition says that the orientation of a plumb bob has to be the same for different locations. Like it doesn't say that the spatial that they have to be parallel.
No, it just says that plumb bobs are vertical.
It just doesn't say that.
And it says that vertical and horizontal are perpendicular. They're
correct.
Okay. Now, if we set a horizontal plane, then any vertical or any perpendicular to that plane, yeah? You okay with that? That would be vertical. A horizontal perpendicular would be vertical.
Yeah. Yeah, but the horizontal is of a specific point, of a specific location.
The horizontal is just horizontal.
Of a specific
parallel,
location. There is no obligation in the definitions that you listed
to the plane of the horizon.
That they have to be valid for any point, for every point.
The horizontal will be
a horizontal plane for one.
It will be parallel to the plane of the horizon
of one location. It doesn't have to be
the horizontal
a horizontal plane of another location.
The horizontal plane, Morty.
That's your assumption, Beth.
No, it's not an assumption.
You're presuming that.
The mathematical description of horizontal is parallel to the plane of the horizon. Now,
correct.
Is the horizontal plane parallel to the plane of the horizon?
If you change location, does the horizon change?
The plane of the horizon stays the same.
Does your horizon change if you change your location?
The parallel to the
does it change?
Plane of the horizon.
Do you see different things if you go to different places?
Oh, Morty.
Yes or no?
When you stand and you are looking out, you can look left, right, forwards, backwards, on the x-axis, the y-axis, yeah? In every way you look, the horizontal will be parallel to the plane of the horizon. That's a geometric term. That's a mathematical term.
Yeah, Beth, even if that's true.
It is true.
Right? Yeah, so what?
Well, that means
if
that
you go to different locations, you see different,
perpendicular to that
if you go to
plane
different locations,
will
you see
be
different horizons,
vertical,
right?
Morty. Mathematically.
If you go to different
geometrically.
If you go to different locations, you see different horizons.
You
right?
see,
you're not seeing the same things around.
It's a horizon parallel to the plane of. Logically, Morty, that means
you go to
all
locations,
horizontal are parallel.
Very simple task
Morty,
in honesty.
You can keep talking as much as you want.
Task in honesty. If you go to different locations, do you see different things? Very simple task in honesty. Can you do it?
Do you see different things in different places? That's not a very good question. That try again, Morty. Let's go.
Why not? Why not?
Well, if you go to different places, of course you see different things.
Okay.
What's up with you? Unless you've got your eyes closed. No, you just see black, don't you? You just see nothing. That's the same thing, isn't it, Morty?
Shush. Obviously, this was a leading question. Obviously, there's something going to follow after.
Yeah, Morty, maybe take a break.
Yeah, thanks.
30 seconds.
How's it going, Paige?
Who's got more? Mobius. Somebody definitely muted Mobius.
Yeah, he was
I was hot mic, and I got me.
Right.
It was a little bit of echo coming through. Yeah.
Okay, so I would just like to say here now that logically,
Morty, please read your DMs. Please read your DMs, Morty.
Logically,
He's trying to say to you,
if all horizontals are parallel to the plane of the horizon, then all horizontals are parallel to each other. Therefore, any horizontal plane will have a vertical that is perpendicular to it. Therefore, all the perpendiculars will be parallel to each other also. Logically. And geometrically. Same thing really, though. And Ligo like we've just explained, is X, Y, Z horizontal plane.
Man, I was thinking the globe heads were muted or something. They were real quiet.
Morty, please read your DMs.
Oh, he's saying I've got a complete mental shutdown on Bev's end. No, it's just the logic, Morty.
You don't understand what horizontal is, do you, Bev? It's not defined by the horizon at all, not geometrically, mathematically, or by anything. It's got nothing to do with the horizon.
Really?
You are a moron of the first order.
How many definitions have you got then, Rumpus? What's your definition?
Horizontal is defined by a plumb being 90 degrees to a plumb bob at one point. It has nothing to do with the horizon.
Really?
And just because the etymology of the word horizontal may have been derived from horizon, that's got nothing to do with how it's actually defined mathematically or geometrically, which is not defined geometrically. There's no reference to horizontal or vertical.
You've already agreed.
Because it's got nothing to do with geometry. It's a physics thing. It's to do with gravity. It's got nothing to do with geometry.
I've got they've got parallel to or in the plane of the horizon or baseline.
Horizon's irrelevant.
Surface.
There's no. If you're talking about the horizon, you're off topic. That's got nothing to do with horizontal. Horizontal is defined by being 90 degrees to a vertical plumb bob.
What's that one there? In geometry, a horizontal line is one which runs left from right across the page. It comes from the word horizon in the sense that horizontal lines are parallel to the horizon. So that's
talking about being on a page.
The horizon
it's got nothing to do with the vertical.
The horizon is horizontal.
Being on a piece of paper, Bev. That's talking about being on a piece of paper.
No, it's not. The horizon isn't on a piece of paper, Rumpus.
Yeah, the etymology of horizontal comes from horizon.
Can I ask you a quick question? When you're done,
yes. Go ahead.
If vertical is perpendicular to horizontal, and no verticals are parallel, then horizontal necessarily bends.
No, it doesn't. Because at any one point on the surface of the Earth, there is a plumb bob vertical, and 90 degrees to that is the local horizontal. If you move somewhere else, if you move 2 feet to the right, the vertical will not be parallel, and you'll have a new vertical and a new horizontal. Each
How do you establish a horizontal
pair are local to a particular point.
How do you establish a horizontal?
By doing a plumb bob and then doing 90 degrees to it, and that's a horizontal just for that point on the surface of the Earth or wherever.
How do you have 90 degrees and one vector?
How do I have 90? Look, I'll try it again. You get a plumb bob.
Try it again.
Let's try it again. It's really simple. You're standing somewhere. You get a plumb bob. You get a vertical, and then 90 degrees to that is a local horizontal and vertical. If you move 2 feet
Real quick,
to
Paige,
the right,
your hot mic
you have
Paige.
to do it again.
Thank you.
Does that not?
Yeah, you have to do it again, and then how do you establish the horizontal if they're not perpendicular to the vertical? Are you talking about the?
Let's try it again. Let's try it again. Let's try it again. You haven't understood what I said. You are standing at a spot. You get your plumb bob out. You then define the vertical. 90 degrees to that is your horizontal. If you move 2 feet to the right, you have to do it again to get the new local vertical and horizontal. Those two horizontals are not parallel.
Do what again? You have to do what again?
God, Jesus Christ! Let's try it again. Let's
just
try
really
it again.
quick. I'm just asking you specifically.
Okay, let's do it again. If you didn't understand, let's try it again.
You can't just start from where I'm at.
Please calm down. Stop being so combative, Rumpus.
You're standing somewhere. You get your plumb bob out. That defines your vertical. 90 degrees to that is your local horizontal.
90 degrees to that. What does that mean, Rumpus? 90 degrees to that. What does that mean?
What do you mean? What does that mean? Do you know what 90 degrees is?
Are you pointing your finger 90 degrees?
Hold on.
Where are we going here?
Okay, listen, Rumpus, I've listened to you say this
Jesus
5 or 6
Christ.
times. Settle down.
Yeah, calm down, Rumpus, please.
Listen,
how can you not understand what 90 degrees to a vertical is?
Rumpus, okay, you've got a vertical, right? That vertical is 90 degrees. Yeah?
No, it's vertical. You've got a vertical. That's what you start off with.
That's a 90-degree angle.
No, it's not. You just start off with a vertical. No.
Straight up and
no,
down.
No, you got it wrong. Let's try again. You get your plumb bob out. That is the starting vertical. That's your starting point.
What's vertical on the plumb bob? What's vertical?
That follows the line of your plumb bob.
No. Okay, so the plumb bob is a physical object, right?
Yes.
The pinnacle.
That defines your vertical.
The line that drops from the axis to the bob is a vertical line.
Correct.
It's at a 90 degrees.
No, it's not. It's not 90 degrees. It is vertical.
It does.
That's the
I've got it.
starting
It
point.
says there, Rumpus.
That is the starting point. You start off by getting your plumb bob out, and the line that forms as it drops to the ground to the actual bob is a vertical. That's your
Is
starting
a vertical.
point.
Okay,
That's
so when
the
you
starting
say,
point.
and
And
then
then from
hold
there,
on,
you determine the horizontal.
You're going to say the same thing
From
again.
there, you determine the horizontal.
The horizontal, what is that? Is that a
90
point?
degrees to the plumb bob you've just dropped.
90 degrees, how far away?
Doesn't matter. Infinitely far.
Infinitely far. So it's a.
So you've
it's a-
defined a horizontal line or horizontal plane that's 90 degrees to that plumb bob. That defines the local horizontal. It's 90 degrees to the plumb bob you've just got out of your
And now
pocket.
that you've got an established horizontal, the vertical is 90 degrees from the horizontal, correct?
Yes, but you derived it from the vertical. You started off with the vertical.
I'm just working
and then-
backwards.
Yeah, well, that's a stupid thing to do. We want to go forward. You want to start off from the foundation. The
I'm just
foundation.
okay. the
No,
fact that
that's
you-
wrong to
the
think
fact
of it
that you
like that.
don't
The
understand
way
that I'm
you
simply
start it off is you get a
reiterating
vertical,
your
and
Right,
then you
can
determine
we
the horizontal.
just a minute, guys, before it turns into a complete and utter shit show? What are we talking about now? Just vertical and horizontal being perpendicular, because we all know that.
For some reason, he didn't understand
Well,
what horizontal. He asked me
What's
what
the
is horizontal.
contention, Rumpus?
I don't know.
Right.
He asked me what horizontal
Okay.
was because he was confused.
Can we just sort this out, right? We all understand what a plane is, right? It's a two-dimensional, imaginary or actual surface that extends out indefinitely, right? Can we all agree on that mathematical term?
Yes.
Right, okay. Now, can a horizontal be a plane?
No,
Well, it's a
line by
horizontal
definition.
plane. I mean, it's a plane that's perpendicular to the vertical plumb bob. I was talking about.
Can you have a horizontal plane, Rumpus?
Yes.
Right, okay. Now, that horizontal plane extends out indefinitely, right?
Yes.
Now, all perpendiculars to that plane will be parallel. Do we agree with that?
Yes. Yes.
Right, okay. Now, what do we call a perpendicular to a horizontal plane?
That's vertical, but it's
Okay.
that's whether it was derived from the vertical, though.
So the verticals would be parallel.
Verticals to that point.
Only at that point.
No, not that point. That
Yes,
plane.
at that point.
No.
Because vertical at another point is defined by a new plumb bob. It's only vertical with respect
A
to the position you
perpendicular
derive the
rumpus.
vertical from.
Rumpus.
If you go somewhere else, it's
Rumpus.
a
You
different
see, you're
vertical.
turning it into a shit show again.
No, but you're just not listening to what I'm saying. I mean, you're either willfully stupid, and I mean, it's just incredible how stupid you
Rumpus,
are. I'll draw
please.
a diagram.
Will
Let me
you-
draw a diagram.
No.
It's the only way.
Rumpus,
It's
no.
the only way to do this.
No. No,
only
you'll
way to do
you'll
this.
draw a circle, Rumpus, and that's ridiculous. So
Here
we're
we
not
go.
having that here.
The only way you
We'll
can
we will
understand.
have we'll go. I'll go through it again quickly. A horizontal plane extends out indefinitely. All
Yes, but it stays a
perpendiculars,
horizontal plane of that specific
all
location.
perpendiculars to that horizontal plane will be parallel. Right?
But there'll only be one vertical. There's only one point they're vertical to.
No, what do you call a
If I draw a
perpendicular
diagram,
to
it's
a horizontal?
Draw a diagram so you can understand.
The problem is when you're extending the horizontal plane that you establish of one point, right? Then it's the horizontal plane of that one point, no matter how far away the point you are.
That's where you're going wrong. You don't seem to understand mathematical principles.
Where in your definition does it say that horizontal planes are universal? That that one horizontal plane is the same for is parallel to another horizontal plane for another location. Where does it say
when
that?
you talk
Where
about
does
a
it say
plane,
that,
when you talk
Where does
about
it
a
say
plane in mathematics, you talk about an indefinite plane. Do you want me to get you a definition of a plane in mathematics?
Yeah, no, that's fine. That's fine. We're agreeing that. But what you did when you made that horizontal plane of that point, and you made it a mathematical plane, then it's still a horizontal plane of that point. The question is, if the point is, if this orientation of being horizontal is location dependent, then so is vertical.
Not according to a water level. A water level is a tool for establishing a horizontal plane of reference.
Here we go. I've drawn a diagram
as well.
showing you a point. So here's the point we're talking about. I'm going to call it
all,
point
all
A.
levels are tools for establishing a horizontal plane of
Here we
reference.
go. There's a point A
And
in my
Rumpus,
diagram. Showing you,
I'm not
okay, you can
looking.
look.
I'm not.
Fine, don't look.
Not
Then. Everybody else can
looking.
understand. Okay,
No,
that's
they're not
fine.
looking at it either.
No, that's fine. No, that's fine. You just don't look. I'll talk to everybody else. So here we've got a point A, and the plumb bob.
Can we just
and the plumb
shut
bob,
Rumpus
the
up?
plumb bob is at point A, and you can see I've drawn in the.
Yeah, we can't see it doing it because
incorrect.
I'm not listening to what Rumpus is talking about.
He's absolute maniac.
Yep. He'll be drawing circles and putting horizontals that aren't horizontals on circles.
Yeah, the old divergent.
Yeah. I know. Rumpus is one of these people that thinks tangent is horizontal, which is completely wrong. Tangents are not horizontals. Tangents are just tangents. Horizontal planes. Go on.
Rumpus is working off of straight up belief.
Mm-hmm.
Rumpus has to, no matter what he's doing, he has to beg the question of being on a globe. He has to directly go back to his model, no matter what's happening. So when you're talking to Rumpus, you're never actually dealing with reality, are you? Can anyone here actually testify that you're actually dealing with reality when you're dealing with Rumpus?
No, they always play my model dictates.
Yeah, he makes it very clear that he's always
Travis.
talking about the globe model.
That's heavy, that.
Did Rumpus leave?
No, he's still up there. He's still live, pretending he's showing something.
Oh, he's showing something?
Yeah.
More drawings? Okay.
Oh, it'll be a circle with tangents on it that he labels horizontal.
A Donegon.
Yeah. Drawing Donegons. So, I mean, I don't know whether they've decided this or whatever, but that tangent point of horizontal that they imagine always leads them, ends them up with bendizontal. That's all they've got.
Bendizontal.
It is bendizontal. It goes around the circumference of a circle.
False.
That's not horizontal.
False.
What's
No,
not? What's
necessarily.
false? A horizontal being a tangent is definitely false. Yes, unless it's on top of a ball.
How did you determine that? How did you determine that?
Because a tangent is touching a curve, and a horizontal is a straight line.
Okay.
And horizontal, it doesn't give a shit about what's underneath it. If you lift it off the surface, like most levels are, then it's not a tangent.
Okay. And how did you determine that horizontals don't form tangents on Earth?
Well, the water level is a tool for establishing a horizontal plane of reference, and that establishes an even altitude. Altitude is above the surface, therefore not a tangent, just a straight line, just a horizontal.
How did you determine that when you establish a horizontal plane using a water level?
It's hydrostatic
having
equilibrium.
You're having a constant altitude.
You
Within the
can't
definitions.
you can't demonstrate the drop from the tangent.
Can't demonstrate the drop off a tangent.
Yeah, it's always going to be horizontal. There's never going to be a point at which the surface drops away from it to become a tangent. Okay, when you
so you just rephrased Beth's claim. Okay, fair enough.
It's
Okay,
not,
so
it's,
that- I mean,
dude.
that's
It's not
the
my
answer.
claim. A horizontal
Yes,
isn't
so far
a
it is your claim.
tangent.
Yeah, that's your claim.
You're
No,
never going to
That's
have a
that's a
drop. Okay, look,
statement.
It's your
which you
claim.
have not proven
It's
yet,
your
therefore
claim
it's a claim.
that a horizontal is a tangent, not mine. That's your claim, dude, not mine.
right, and you can
No, I
demonstrate
didn't make
on-
that claim.
Morty,
I asked you how you determine that it's not.
Okay, listen very carefully. You can demonstrate a tangent on a circle on a piece of paper. You cannot then go out on the ocean or on a massive stretch of land and produce a tangent.
Yo,
you can't
what's up,
do
man?
it.
I gotta get out of here, y'all. Y'all have fun.
Yeah, I'm
Enjoy
gonna
it.
have to be going soon as well.
All right, I'll see y'all.
Yeah, catch you later.
You're never going to produce a
See ya,
tangent.
Claire.
Morty. You're always
All
going
right,
to have
see
a
ya.
horizontal.
I mean, I
Every-
agree. There's a problem with the scale and the physical properties of solids and other materials I can find to represent a straight line. Yes, I'm gonna have that. There are limitations to that. There are practical limitations to that. To showing that
The only thing that you can do,
differentiating it in a tangible way. Yeah.
listen, the only thing that you can do conceptually over massive distance is elevation, right? So if you start a horizontal line physically, and you're able to take that horizontal line and maintain equal elevation, and then all of a sudden there's a drop in the topography, right? And then the topography comes back up and meets that horizontal line. That's not a tangent. That's elevation. Okay, that's going to happen for 100 miles. It's going to happen for 500 miles. Sometimes you're going to have a higher elevation, but that horizontal is going to cut through conceptually in a straight plane. It's never going to be, when the topography changes elevation, a result of curvature. It's never going to be a tangent.
How did you verify that?
My question to you is, how would you know the difference between elevation and curvature once you came across a deviation from your horizontal?
Difference between elevation and curvature.
Right. So you've got a horizontal, and let's say for 5 miles you've got no deviation, bro. It's just straight and planar. That's awesome. And then all of a sudden you've got a drop. Is that curvature? How do you know? How do you know it's not elevation? Because then 5 miles later, the topography is higher than your horizontal. So what, now the Earth is now convex?
Well, would you say I can know the elevation? I can know the elevations of different points without having previously, without knowing if that curvature is there or not before that?
What curvature? Where do you get this idea of curvature?
Well, you were talking about it, right?
No, I'm talking about.
Yes, you were talking about curve. You were talking about if I.
No,
how I
you were
differentiate
imagining
from
curve. You
elevation,
dream
right?
about it, dude. He was
No, I'm
talking
not
about
dreaming
horizontal
about it.
planes.
I'm referencing what Etherban said.
Elevation change. He said. I heard him.
Yeah, I'm
and
talking
he
about
asked me if how I would differentiate it from curve.
Yeah.
That's because you introduced that.
I didn't introduce it. I didn't introduce it. I asked Beth a question and you jumped
Think you
in.
live on a ball. Of course,
No,
you're the one
I
who
don't.
Stop
Otto,
trying to win the actual
please don't project
words
your
that you're
enemy
saying.
onto me. Please don't do that.
Stop
I've
trying to win just the sentences that you're
a
saying
lot
and
of
listen to what
times
people
that
are
I have
trying
not
to
personally
tell you.
verified it,
Wow,
that
where's that
I've not
music
made a
coming from?
conclusion on that.
Somebody
So
party.
please
Talk over
stop
anyone and then
please
just
stop
cry like a
projecting
little
this on
bitch
me,
when
Otto.
somebody
Please,
talks over you.
Whose is the
stop
party?
projecting this on me. Okay? Please stop.
Somebody at a
I'm not
party.
projecting. You cried
hear the
like a
music.
little
Yes, you
bitch
do.
before when you
Yes,
got
you do.
interrupted.
I'm telling you very
Morty,
clearly what
Morty,
my
stop
position
it.
is, and you're ignoring it.
Is it Morty's party, dance party? That's too
I
much.
think it was
Too much.
And you're crying. You
Oh
want
no,
to
it's
do.
Paige.
It's his party.
Paige, you got feedback.
Oh, sorry.
Paige, you got to drop and come back. You got real bad feedback.
Wow. Listen, guys, I'm going to have to get going soon, but I think 3Space is still on. We got some mods around to keep an eye on it. I'm going to be shutting my stream down.
Yeah, I'm going to be here a while. Everybody's been good. You know?
Yeah, sweet. Well, I'm going to shut down the try thinking and then get off. So anybody will probably come back and do this a bit more. It seems like it's quite good fun, this. So I'll stop streaming now.